Now we're recording, okay? And where we're going to begin today is with the syllabus, okay? Now, time out. I'm not ready for the class, okay? No, I haven't got Blackboard set up at all. If any of you went out there and checked Blackboard, you see nothing's there, okay? Sorry about that. But I'm also the math department chair, so all we've been doing all week long was moving classes around, canceling classes, moving instructors around, calling students, telling them the classes were canceled. I have had zero time to set up the class, okay? Now, I'm going to show you the syllabus that I used last spring, and I believe it was last spring. Yeah, it was last spring. Obviously, some of the information here is wrong. My personal information, that kind of stuff. But we'll get into the course description. All that's pretty much fixed, okay? With maybe some exceptions. But I'll go over this to begin with. This is Math 126, Cal 2. Everybody in the right class, right? Good. Okay. It says the software and Blackboard supported class, blah, blah, blah. Okay. We're meeting. This was the evening class last spring, but it's going to be Monday and Wednesday, and they changed the hours on me this summer. Actually, they've given us way more hours than we need, but we'll take advantage of that. Starting at 11:30, right, and going to 2:25. Is that right? Okay. So that's what we're doing. Really more hours than we need, but we'll use them all, I hope. Okay, Bessemer campus, and this is the right room, 2:25. So Monday and Wednesday. I'll get this corrected before I put it out there on Blackboard. Okay? My information here. My name's Charles Fowler, if you haven't picked up on that yet. My office is room A265. Now, 2 or 3 of you may remember where this is. I think you know because you just passed it yet. But if you go out the door here we are right here, take a left, go down this little half flight of stairs here, and then almost hit the wall at the end. Don't hit the wall at the end. Right before you get there, there's a stairwell, and just before the stairwell is an office door that's 265. So it's right down there, the last office on the left, the last anything on the left before the stairwell. It's right in between the mechanical room with double doors like this and the stairwell door. So that's my office there, 265. Now, I'm there Monday through Thursday. Most of the time on Friday, I'm on the Birmingham campus. We're not going to have any Fridays this summer. Okay, well, I'll get to that. So there's my office number, 265. Here's my phone number in my office, 929-3449. But now I'm going to tell you my office hours in a few minutes. Okay, that's going to be next. This is embarrassing, but it's true. Please don't bother leaving me a message. Right now, I'm not even sure the voicemail is working properly, and besides, we were gone for most of a week. I haven't had a chance to clear or check any voice messages, and I don't know when I'm going to have a chance to. So that's why I say don't even bother. I'm not even sure it's working. Call me only during the office hours, and if I'm not there, hang up and call back later during the office hours. I'll tell you those hours later. But there's my number, and usually if I'm in the office, I'll be answering. Now, if I'm on the other line, I can't answer immediately. I may miss you that way, but just wait a few minutes to call back. Here's my email. For most of the employees of the college here, is first initial, last name at lawsonstate.edu. Pretty simple. There are a few people who have such similar names, like a Sharon Williams and so Serena, not Serena, but something other Williams. They have to use their middle initial too. But most of us is first initial, last name at lawsonstate.edu. Now, on Fridays, we only have like 3 Fridays this summer, and I'll explain that in a minute too. I'm over on the Birmingham West campus. It's called the Academic Building, and the building is also the B building, so it's B122. That's my boss's office suite. Is Dr. Carl Pruitt is the Associate Dean for Transfer Programs. And if you go in the office, you'll see a secretary desk right there. He's in the big corner office. Behind the secretary's desk is a copy room. That's my office on Fridays, okay? It has a phone in there, but the last several Fridays it hasn't worked. So I don't think they're going to repair it because it's used to be Monday through Thursday. This was the office of the grant coordinator. Okay? I don't think she works here anymore, and when her phone went out, they didn't bother to repair it, so it's just a dead phone there. So don't call that number. And even if it works, don't leave a message because it's not my phone number. That's the phone in the office, but it goes to her voicemail, not mine, if they ever get it fixed. Okay, so don't bother calling that. Let me give you a better number for Fridays. 929-6377. That's the secretary's number. Her office is right outside mine, and if I'm there, she'll give me the message, or she'll call me in and I'll answer the phone. If she's not there, I usually try to answer her phone if it's ringing. So you should get me if I'm in the office. But don't leave me a message on that one either. That's, again, 647. Say again. Okay, I think I said 63. I believe it's. I have to picture the keypad. 6. I think it is 6377. I was thinking it was maybe 645. I believe it's 6377. I'll have to check for that. When I'm calling her, I know right what to hit, but I can't think of it now. Okay, now about Fridays. Because these are old buildings, hard to keep cool, and typically in summer we have very few Friday classes that ever made and almost no Saturday classes that ever made. They decided to put us on 4-day work weeks in the summer, so they only have to cool the buildings Monday through Thursday. And so beginning in June and July, no Friday, because college is closed on Fridays, and of course closed on Saturdays too. But this Friday, day after tomorrow, next Friday is the 31st of May, because we're only closed June and July. We work those 2 Fridays. And then in August, I think the first Friday in August will still be on campus, and I'll be there then. So those are the only 3 times I'll be over there. The rest of the time, we're working 4 10-hour days for our 40-hour work week. Okay. Doesn't seem like anything changes, except I don't come in on Fridays now. Okay. So let me give you my office hours for this summer, as I know them now. They may change because I've got to meet with the Cal 3 class tonight to see if it's going to make or not, because it was right on the borderline. I don't have an instructor for it, so I may wind up teaching it, and if I do, we're going to try to adjust the hours. So I don't know if these are going to be fixed. But for right now, I'm here from 8 to 8:30 every morning, Monday through Thursday, 8 to 8:30, because I have an 8:30 class all 4 days. And then on Mondays and Wednesdays, this class ends at 2:25. For right now, 2:25 until 2:30 until 6. Okay, those are my office hours now. If I wind up teaching the Cal 3 later in the day, we may move it up and eat up some of those office hours, or we may move it to Tuesday, Thursday, or I may wind up not teaching it at all. So anyway, for now, it's 8 to 8:30 Monday and Wednesday. Actually, 8 to 8:30 is all 4 days, and then on Mondays and Wednesdays, 2:30 to 6. Okay. Now, Tuesday and Thursday, 8 to 8:30 again is screwed. I have a 3-hour class then, not a 4-hour class. So that ends at 10:45. So from 10:45 until 6. Right now, that's what I've got. Again, if I move that Cal 3 to a Tuesday and Thursday afternoon, then that may eat up those office hours. But for right now, Tuesday and Thursday is 8 to 8:30 and 10:45 until 6. Okay. Now, later I'll show you something about, and on Fridays, the Fridays we are working in Birmingham, that'll be 8 to 12. No classes, so 8 to 12. I'm usually there before 8 and usually there after 12, but officially those are my office hours. Yeah. Okay, now, something else I was going to say, but I've forgotten it now. Okay. I'm going to first show you the course description. This is not something that I made up, or anyone here at the college made up. This is something that was developed at what they call what do they call that? And just articulation. An articulation committee of two-year college system and the public four-year colleges and universities in the state of Alabama. Not the private ones, just the public ones. They formed a committee together and they came up with this. If we teach this, they give you credit for it. Okay? So this is the second of 3 courses. Now, I did make a change here. Whoever did the typing of this, I think they've corrected it now. The head in the system, the second of T courses. They left out the HR. I don't know why I put in the HR, but now I think they've corrected it on the system. The second of 3 courses in the basic calculus sequence. Topics include vectors in the plane and in space, lines and planes in space, applications of integration such as volume, arc length, work, and average value, techniques of integration, infinite series, polar coordinates, and parametric equations. Okay? That's the course description they get. Now, this goes across any book we choose to teach or anything else we have to pick and choose. So the order, they don't say we have to teach it in this order. I go by the order that's in the books, okay, that we're using. Some books have different orders. I'll change those around. Okay. So I'm going to hang off talking about what order we're going to do it until I find out where all of you are. Okay, because I bet you took Cal 1 years ago. You two took it last term, and y'all may have taken it last term, but you probably use different books at different schools, so it's hard to say where everybody is. So I'm going to try to determine that, and then we'll come back and do this. But I'm going to give you a general view of it now. I was starting not to do this, but I'll give you the general view. Okay? Looking at the book I'm using. Now, before I get into that, let me make a guess. Most of you took Cal 1 recently, some of you, right? Okay. And as in last term or sometime recently. My guess is most of you, 2 of you, probably used this book. Most of the rest of you did not. Am I right there? Okay. So did you purchase a calculus book? You actually have one. Okay. I do not suggest that you purchase this book. You can if you want to, but if you have a calculus text already and you're used to that, find the topics that I'm going to tell you about here, and it's probably going to be so close you can almost spit on it, okay, that they're going to be that similar. They may change the order a little bit, but the topics, I've taught from so many different books, and hardly ever. Maybe chapter numbers change, and sometimes the order, but generally they have almost the same topics, okay? Now in this book, Cal 1 was chapters 1, 2, 3, 4, and probably a little bit of 5. The 2 of you that were in it last time, we did part of 5. Ran out of term before we ran out of 5. Chapter 6 in this book is differential equations. That's another course, okay? Chapter 7 in this book is applications of integration. And look at here. Right there. Applications of integration. Okay? So that's where typically I start Cal 2. Okay? We'll talk about this a little bit later. Chapter 8 in here is integration techniques. Techniques of integration. Right there. So I will be doing chapter 8 next. At least part of it. You may not do the whole thing. And then our chapter 9 is infinite series. There it is right there. So we'll do that. Now, typically, we don't have time to do that whole chapter. So I'm probably only going to do 9.1 and 9.2. Okay? When you get your books, you can find the title. My nose is itching and you don't have that. Okay, next. Our chapter 10 is conics, parametric equation, and polar coordinates. Polar coordinates, parametric equations. There's chapter 10. And we'll do, typically I do 10.2, 3, and 4. Because conics aren't mentioned here, so I'll skip conics. You can review that on your own, but we just don't have enough time to do them all. Okay? Then our chapter 11 is vectors and the geometry of space. And look here. Topics include, in this one, vectors in the plane and in space, lines and planes in space. So there's that. And that's what we go there. So that's chapter 11. At least 11, 1 through 5. Okay? And that's where I typically teach it. Now, what I want to find out from y'all, and I'm going to do it a little bit later. Well, let's go on to it now since we're talking about it. Does anyone feel like they need to review anything logarithmic, exponential, and other transcendental functions? Or did y'all cover that okay in Cal 1? Everybody feel okay with it? So we'll start with chapter 6. If we need anything, we'll go back and pick it up as we need it. Okay, so we'll start, I'm sorry, not 6, chapter 7. Okay, so we'll start where I normally do. But I like to, beginning of a term, make sure we're all starting on the same page. I don't want to put anyone at a big disadvantage, except Jake. Okay. All right. So, and by the way, what I was talking about before, Lawson State finished third in the state, in the Alabama Community College Association in baseball, and Jake is infielder or outfielder? Outfielder. Okay. So that's why I was congratulating them all. All that was going on the last week we were here, and everybody was really excited about it, but that was off campus, so we didn't ever find out until now how we want that. All right, so that's the course description. You get your book, if you got a book, and then find those topics. And I bet you they're going to be very similar to applications of integration, techniques of integration, infinite series, polar coordinates and parametric equations, usually in the same chapter, sometimes in reverse order, and then vectors in space, or something like that. That's what we're covering, okay? And if your book covers it, you know, calculus is the same no matter who writes the book. So I think you'll be able to deal with that. All right. Now, prerequisites, they have all this blah blah about high school and stuff, but basically it's made a C or better in 1.5, which is Cal 1 for us. Maybe different for us. But I assume that's why you're here. All right. Now, I've already talked about the textbook, but let me give you the details of the textbook. Okay. Text that I use is this one, Carson. It's Calculus by Ron Larson and Bruce Edwards. It's the 11th edition, and this is the last term I'll be using this book for Cal 1, okay? Because he has another text that includes the transcendental function, early transcendental functions, in the chapters where they belong rather than being separate in chapter 5 like they are here. So I'm going to that text in the fall, but it won't affect any of you, because if any of you are back here in the fall to do Cal 3, we'll be using this book. We'll use this book for Cal 2 and Cal 3, and then the spring we'll use it for Cal 3, and then starting next summer we'll be using the new book, so you don't have to change books. Now, this is published by Cengage Learning. I don't mean to be negative or anything, but I really don't care for them as a publisher. I have not found a calculus author, except maybe the old Thomas text that Bill and I both used in college, but he's been dead for a while. But I haven't found anyone who has written a better modern text than Ron Larson. I'll give you the reasons later. There are some drawbacks, but I'll give them right now. He has 3 absolutely free websites that anyone can go to anytime they want to. Your great aunt in Michigan can go to these websites. She doesn't have to buy a book. She doesn't have to be enrolled in a course. Anyone can go to these. The first of these is larsoncalculus.com. Now, there are places in the text where they give you an example. Okay, here's one, an example in chapter 5. Example 5 on page 326, it says, see larsoncalculus.com for an interactive version of this type of an example. So usually in every section there's at least one and maybe a couple of these examples they give. You can actually go and get more information about it. So that's a great feature. Absolutely free. You don't need a code or anything else. Anyone can go there. Now, at the end of each section, I think I'm on the page back here. End of each section, there's exercises. Okay? This is the one for morning class. And they have exercises here. The odd number exercises have answers in the back. Most books have that. Okay? So I usually assign the odd number exercises so you can do them, check your answers. If you can't get the answer, figure out how you missed it. If you can't figure out how you missed it, in the past, that was frustration. It was spending a lot of time or having to wait till the next class and ask a question about it, even if it's a weekend away or something like that, and then you forgot what the question was, okay? Or you were too embarrassed to ask, or something. Well, up here at the top, and it's on the back of the book here too, calcchat.com, calcchat.com. And at the top of every section it says, see calcchat.com for tutorial help and workout solution for the odd number exercises. They have it there for you. Try it yourself first. Check in the back. If you've got the right answer, go on. Don't get the right answer, see if you can figure out how you missed it. If you can't figure it out, don't get frustrated. Go to calcchat.com. They worked it out. Free tutorial help. Okay? Now, in addition to that, many of the exercises, not all, but many of them, there will be groups of exercises. This had 11 in this group, or 9 in this group. And if you see one of these QR codes, okay, you can, with your phone, I like that, and it takes you right to that problem, the one that's in red, okay? See, the other numbers are black, that number in red, and it has it tells you here, it's calcview.com. It presents a video solutions to the selected exercises from the text. Watch the calculus instructors progress step by step, blah, blah, blah. So it's even more detailed than CalcChat. But it's fewer problems. Usually only one, and sometimes not one from every group of exercises. Okay. So that's why I like this author. As Bill and I both know, he's not as good as Thomas was, but he has those things. I've never found another book with that. Now, if your books have something better than that, let me know. We may change to yours, but this is pretty good. Now, if some of you are wanting to buy the text anyway, okay, not going to use the one that you have, or you just rented the book one that you had back then, you can still rent this one. You'll have to go to the bookstore and find out that. Or, and this is one good thing about Cengage, they have this new program. It's called Cengage Unlimited, and for $119 per semester, you can use any Cengage book that you've got a course using that. I'll go over which those are. Are any of you in physics this summer too? Okay, the physics text. If you haven't bought it yet, you can buy it through Cengage.com. No, Cengage Unlimited. Okay, and I'll let you read this. They make us put this in. To me, this is advertising, and I don't think that belongs in a syllabus, but they make us put it in. There it is. You can read it. Again, I don't have this on Blackboard yet, but when it is, it'll be there. But you can read it through the YouTube video right now. As soon as it gets loaded. Okay. So here's all about Cengage Unlimited. Now, starting down here are all the courses we offer, or at least offered in the fall, or spring, or whenever, that use the Cengage text. So if you're in any of these, that same $119 gets you these two. Okay, this book to buy off the shelf is more than $119, but you can get all the text that use Cengage books for that one price, $119. Now, is it this text? No, it's an e-text. It's an e-book. Okay, and you only have it for that term, unless, and we'll see the other details on that later. But if you want to buy a paper copy, it's not like this. It's not hardbound. It's soft bound, and it's a lot less than what it would be on the shelf. So, because you've already paid the $119. Now, it may be that I have to give you a code, and we'll get to that in a minute. But if I have to give you a code, I've got to get with Cengage and get the code. Sometimes they're slow with it. So I'll get that as soon as I can. I think you get the first so many days free, so you won't have a problem with that. So these are the other courses here at the college that use Cengage text. There's the physics course right there, all the physics courses except 112, and you're not in 112. So that would be that. Now, the 119 is the cost for one semester. If you know you're going to be here for a full year, then you can do 179 for a full year. I think that includes 3 semesters. And if you're going to be here 2 years, if you're just getting started, which none of you are, that would be 239. So there are some other breakdowns. But you do need, when you buy at the bookstore, the receipt that you do, you pay the $119 there, all that will be a pen that you'll need to use to access your book. Okay? So don't throw away the receipt. Okay. So I'm not going to go into this because most of you probably aren't going to use it. It'll be out there if any of you need to read it. Okay? And here's how you do a hard copy of the textbook for $7.99, $8. And they say hard copy. I thought it was soft copy, but they say hard copy. No. Hard copy meaning on paper, not hard bound. Different. Okay. I didn't think they did that much. Okay. So, but that is a rental, not a permanent. You have to redo that every term with the $119. Okay. All right. That's all I'm going to go about Cengage Unlimited. But if any of you want to use it, it's a lot cheaper than Blackboard. And if you want to do it just for the summer, if you got that in your budget, you can do that. Blackboard, I do not like this, but they say we have to put this in. I don't mind Blackboard. All courses must use Blackboard to gain access to vital course information, such as the syllabus. Okay, and again, let me remind you, it's not there yet. Okay, I don't have anything on Blackboard yet. Hopefully, I can get some done today, maybe some done tomorrow, maybe a little bit done on Friday. And you do know the good news, bad news situation coming up, don't you? The good news is Monday is Memorial Day. The bad news is we won't be meeting. Sorry about that. Get over it. Okay. So we won't meet again until Wednesday. So hopefully by next Wednesday, I'll have Blackboard at least start setting it up. I don't know if I have it fully done, but I'll hopefully do it. So once it's there, you'll gain vital information such as the syllabus, handouts. Well, guess what? Most time if there's a handout, I'm going to hand it out to you. So I don't usually do that in Blackboard. PowerPoint shows. Now, they're not there yet, but they will be. The same one I'll be teaching from later today, that will be there. Every section in the book has a separate PowerPoint show. I'll put them all out there. Now, let me tell you where they're going to be. All right. Are any of you familiar with our Blackboard? I know Jake and Bill, and you may not be familiar with what we're using now, but Ricky. But anyway, when you go to our page on Blackboard, Cal2 on Blackboard, the home page, there will be a series of tabs that actually go down a couple of pages here. And on the instructor side, they're blue. I don't know what they are on the student side, but a bunch of tabs. And they're split into groups of about 7 to 10 things per group, you know. In that first group, one of those things says something like course information. I may not say those exact words, but see, they change this about once or twice a year. I never remember what it call it in the different years. But there's something like course information. That's where I'll put the syllabus. Okay? Syllabus will be right there under course information. Then the next tab, I think below it, says instructor information. And that's where I'll put, and I don't show it here, my locator card. Now, I don't have that done yet. I'll show it to you later, but it's not the current one. But that shows when I'm on campus, when I'm off campus, when I'm in class, when I'm out of class, when I'm at lunch, when I'm not at lunch, which campus I'm on, all that kind of stuff, which course I'm in, what room I'm in, all that kind of stuff will be there. That will be under instructor information. We'll go down to the next grouping of topics, and one of those says something like course handouts, PPTs in the PowerPoints. That is where I put the PowerPoint show. Now, other things that will be there, I'm going to get to it in just a minute, you have a research paper due, okay? I'll put all the instructions for that. We're going to go to that in just a minute. So that's going to be there. Then all the PowerPoints are going to be there. They'll be in static, just like I take them off the flash drive. I just load them right onto Blackboard, off of the flash drive. Okay. Every section we could possibly do. Probably some we won't be doing, but every one we'll possibly do in here. Okay. So they'll be there in that second grouping there. Activities. The school may post some of those. I usually don't. Assignments, I'll put the research assignment out there. But in reality, actually all your homework assignments are going to be there too, but they're going to be there in a slightly different fashion. And get your name, please. Craig? Okay. You go by Anita? Okay. All right, welcome to Cal 2. We're only missing one person. This is amazing. This is great. Now, here's the part that's not quite so great. It's listed here that at least 4 of you may not have completed payment yet. And here's why that's not great. Because they threaten, I don't know if they're going to do it or not, but they have said at some point they're going to remove all unpaid students from the roll. Okay? And if they remove unpaid students from the roll, that means you have to re-register for everything. Okay? So that's one thing that's not great about it. Other thing that's not great about it is then they look at the numbers, and if they don't see enough number of people in the class, they'll cancel the class. Now, I don't think they're going to cancel this one because I think they're going to have to do it over my dead body to do it, and I won't know if they did it or not then. But if they, because I have 1, 2, 3, 4, 5, 6, 7, 8 paid students here, paid for Cal 2, I'm going to teach Cal 2, okay? But they will threaten to do that. So they say we're supposed to have 15. This looks like we only have 12 now, but I talked them into running the course. So what I'm going to do is I'm going to teach a differential equation course for 5 students, so I can add that to the 12 in here, and then we have more than 15. So basically I'm doing the differential equations for free just to get both classes to pay. But the bad news was this morning, my Cal 1 class had 15. I said, good, except not all of them are paid. More of you are paid than are paid in that class. So I'm still sort of, I don't think, again, I don't want to be lying on the road when they do it, but that's the only way they're going to do it. Okay, so anyway, those will be, I'm talking about Blackboard now. It's not set up yet, but as soon as I get it set up, these things will be there. So the PowerPoint shows will be there under that third tab down here in the second group, whatever tab that is, says PPPs. The research assignment will be there, the PowerPoints will be there. Now, I did say research assignment is there, and I said the others won't be. I don't type out what your homework is every time. What I do when we finish a section, I'll give you the homework exercises for those sections. I'll do it while I'm recording, so it's going to be there under the YouTube video. So you have to go to the video to get it. If you're here, you've heard it, you know what they are. If you're not here, go to the YouTube video to get it there. Okay? So they will be there. And the YouTube video link will be under that thing of PowerPoints and more. You know, that same one that has the research paper assignment, the PowerPoints. Now, what else is on that link? Or in that section, okay? Over the years, either I found or students have suggested to me websites they found helpful in the course. So if I've given one, I put it there on YouTube. Not YouTube, on Blackboard. So those will also be under that tab in the second grouping that says handouts or PowerPoints or whatever it says. You'll usually be able to find your way through that. It's not that many to choose from. Look at them all so you see something. Nothing's there yet now, so wait until something gets there. I'll tell you when I got it out there. Okay. Announcements, that usually comes from the school. Unless I'm making announcements, usually at the first of the thing, I'll turn on the recorder, and right after I call the roll, turn on the recorder, and if there are any announcements, I'll make them there. So you can get them to the YouTube video. That'll be there too. I do not like this next sentence. Failure to use Blackboard will severely damage your ability to pass the course. Boy, that's quite an overstatement in my mind. If I were allowed to change this, I would write it as the proper use of Blackboard could greatly enhance your ability to do well in the course. It's much more positive, and I think closer to reality. Now, some people may teach their courses strictly through Blackboard, and if you don't follow Blackboard, you're going to fail. I don't do it that way. I teach the course, Blackboard is a tool. Okay? That's how I look at it. Then the next sentence, I don't care for much either. Students should always check the Blackboard announcements and task pages prior to coming to class. Why would they have that sentence in there? Say again? You may not have class. And you were in my class last time. How many did I cancel last time? 0. Okay. So to me, this is implying, in case I've just decided not to have class that day, I'm not going to just decide not to have class that day. If something comes up, like I can't even imagine what, severe health problem or something like that, that just pops up all of a sudden, more than likely I'm not going to say from the hospital, "Brad, could you please bring me a computer so I can sit on Blackboard?" No, I'm not going to worry about that. If I'm able to get here, I'm going to be here. Okay? Not going to worry. Okay? Even if there's traffic there, I had to say that to my morning class. If there's a major wreck on the interstate, I may not make the 8:30 class. I'm going to be here by this one. Okay? Now, there may be other things that come up completely out of my control. If they are, the odds are I'm not going to have a chance to put it on Blackboard. If I know something's coming up, I'm going to tell you ahead of time. Okay? And again, you can get that through the YouTube video. All right, too much of that. Let's move on. All right. I'm trying to get all this on one page. It worked. Perfect. Professional competencies and objectives. The student learning outcomes for the course are: students will apply definite integrals to volumes, arc length, and work. Again, in this text that we're using, that's chapter 7. Okay? Application of integration. Students will use different techniques of integration, such as integration by parts, trigonometric substitution, partial fractions. That's chapter 8. Integration techniques. Students will work with infinite series and series. That's chapter 9, infinite series. We'll probably only do 2 sections there because we just don't have time for much more. Okay? Students will solve parametric equations, use polar coordinates. That's chapter 10. Okay? I'm sorry. Did I mistake that before? No. Yeah, that's right. Okay, sorry. 4 is number 10, chapter 10. So chapter 11 is down here. That's why I was missing chapter 11. Students will use vectors in the plane and space to define lines and planes in space. That's chapter 11. Vectors in the geometry of space. Okay? Students will research and write on a topic or a computer application in calculus. And that's your writing competency. That's your research paper. Okay? And I didn't put the overall competency, but I'll tell you about that later. Okay. Now, notice here, after each chapter, we have a test. And before I go any further, let's take a little poll here. Would y'all rather have in-class test or a take-home test?
Take-home.
What? What a shock! My goodness, I wasn't prepared for that. No, okay. Frankly, I'd rather you have that. The reason is, there's multiple reasons. If we had to do in-class test, then I would feel obligated to keep the test short and simple enough that you could finish it in, say, an hour or some finite time period. And then I really wouldn't feel like I'm testing you over the material very well. So for a take-home test, you're going to have a little bit more involved in the things. Basically, critical thinking. How do you go about solving this? Not do this. How do you do it? So there may be a little bit of that for that. So that's the one reason I prefer the take-home test. The other reason, if you were my employee and we were working on some big project or something, I wouldn't say, okay, I need you to solve this problem, but you can't use any outside resources and you have 1 hour to do it. I would not trust what you gave me. I'm sorry, I don't mean to be negative. I want you to use every outside source that you can to get it right, okay? I want a correct answer, okay? I want to solve the problem, okay? So that's the other reason I have a take-home. That's what real life is going to be about. When you apply calculus to whatever field of study you're in, you're going to, please use all the resources of your availability to get it right. I guess that's maybe a few other things, but that'll do for now. Okay. So anyway, there's your, okay. And because chapter 9, remember I said we're only going to do 2 sections in that, we're going to combine 9 and 10 together and have the 9 and 10 to get there to test on 9 and 10. There'll be 2 sections here, I think 3 sections here. And so we'll have 1 test on those 5 sections. Now, since we may have more time this summer, if we do, I may go back and pick up a few things I skipped otherwise, but we'll see how that runs. All right. Any questions on that? Okay. That's what I'm going to require of you. Here's how I'm going to evaluate that. And someone else put this first sentence, which to me is just totally redundant. But anyway, a research paper is required for the course. Notice the verb required. Not optional, not possible, not, it's required. It will count as a test grade, and that grade cannot be dropped. Okay? We'll talk more about that later. Then the chapter test will be given after each chapter or unit. 9 and 10 goes as a unit. Okay? The lowest chapter test score may be dropped. And again, notice the verb here, may. Why do I put may, not will? Well, what if you don't do a paper? That's a big 0. You're going to need every test score you can to bring that 0 up. Or you do a really lousy job on the research paper, you might need good test scores to bring that up. So I only drop a test score if it brings up your grade, not if it lowers your grade. Okay. Now, the last test that I'm calling the final exam now here may not be dropped and will count as 1 test score. Now, that sort of implies it's comprehensive. It may not be. It may just be the final test that we do. But see, even the final test is going to incorporate everything that went before it to get you to that point. So that is going to be basically, I used to have it in the table, your overall competency is that last test, the final test. So I don't hear it often, but occasionally I'll hear, I made all A's on all my tests, can I accept the final? No. Okay, the final may not be dropped. Okay, so the last test is not dropped. Now, if we finish everything that I've stated, and you've been tested on everything, and we have time for a comprehensive test, then we'll do one, and that will be your final. The odds of that happening are pretty small. I've never had that happen in a calculus course, because we're always still covering material right up until the very end. Okay, everything's, all the assessments are on a 100-point scale, and if your average is in the 90s, you get an A, 80s B, just the same as always. Don't go down here, folks, okay? That's not helpful, okay? And there's a couple reasons. Most of you, I think, are transient students, right? Okay. Just a couple of you, maybe 3, are Lawson students. I think I'm correct on that. I don't believe a D or an F is going to go back to your home institution, so don't go there. For those who are Lawson students, my guess is you're pre-engineering or something like that, and if that's what you are, then that's not going to count either. A D, certainly not an F will either. The only way a D will count at Lawson is if it's in a non-major course. And for pre-engineers and math and physics, calculus is counted a major course. Okay, so you can't make a D or an F there, which I don't think any of you should, or even are in danger of. And we'll get to that a little bit later. If you notice, I said the times are a bit long. I think I mentioned that. And that's because our administration can't do math very well. They lengthened courses this summer because they said we didn't have enough hours last summer because of SACs. Everything's blamed on SACs now. The Southern Association of Colleges and Schools, they're an accrediting agency. We're under a SACs review now. That's every 10 years you have one, whether you need it or not. And we're in the process of that now. Someone got panicky that we didn't have long enough classes in the summer. So they lengthened them by 25 minutes, for a 3-hour course, 25 minutes every class. Way more than what they should have. And so anyway, here, another illustration, administrators don't understand math. Here's the way this was originally written. The instructor always rounds upward. That's what this first sentence always said before. Always rounds upward. But then this was the example. This is straight out of what was written. For example, a 79.5 will be rounded up to an 80, but a B. But 79.4 would remain a C. Well, rounding, that would be rounding down. So I changed, because she said, the person said the instructor always rounds up, but then gives the example of where they round down. So I just changed it to the instructor rounds normally, because this is how you round, okay? So that, it seemed like a really stupid thing to put here. I wasn't supposed to change it, but I could not have it being contradictory, so I changed what I did. All right, attendance, try to be here, folks. I know I'm recording all the classes, but guess what? And this truly has happened. One time, I could not get Screencast-O-Matic to come up. No matter how hard I tried, I had to teach that class without it. I called down to find out what happened. Nobody knew. The next class still wouldn't come up. Finally, at the end of the day, I called down again and say, okay, I still can't get it. Oh, we forgot to pay the bill. No, someone had messed up and not sent through a requisition. So they cut us off. So we went several days that term with so try to be here. Now here's how I've tried to overcome that, but it isn't a perfect fit. When you go, I don't have it set up yet, but when you go to the playlist in Blackboard and YouTube, in that playlist, right now, every class that I've ever taught in Cal 2 is in that playlist, unless it's been the same material covered again. If it did, then I would have deleted the previous one. So everyone is out there. Everything we did last term, every time, if we covered more of the previous term, is still out there. Okay, so all of them are out there. There is some overlap, for sure, and there may be a few gaps, for sure, but it's all there. And when I do a class, like today, the syllabus, when I load this one on the playlist, I'll take off the one on the playlist from last time. So you always have close to being the whole course there. The stuff at the top will be from the previous, the ones at the bottom will be from this term. So you can look ahead, look behind, whatever. But it's better to be here. Try asking the YouTube video a question you're not going to get anywhere, okay? In class, you can ask questions, okay? So, try to be here. Now, I'm glad this is on the page while that's on the page. If either circumstances or whatever comes up and it looks like you're in danger of making a D or an F, no way you think you can pull it up to a C, please withdraw from it rather than hurting your grade point average. The only negative to withdrawal is financial aid. If you withdraw from a class, financial aid will repay for you to retake it once but not twice. Okay? But guess what? You make a D or an F, you're going to have to retake the class, and financial aid will only pay for it once and not twice. So there's no disadvantage to a withdrawal over a D or an F. The advantage is this doesn't hurt your grade point, and that does. Your school's not going to take it, this or that, but rather than messing up your grade point, go and withdraw. Okay? I don't think any of you should wind up in that category, but just they have it in here. That's what I say about it. All right, makeup work. For some reason, I have trouble. We have to have it in here, but it's a term assignment on the paper, take-home test. What in the world is makeup work? No. If you aren't here for the day I hand out the test, pick it up the next day. Get it back to me. Now, let me say this about take-home tests, though. Try to get it back to me within a week. I always give you at least a week to work on it for two reasons. The first reason is you always have one day that you can come and ask questions. Say, I don't understand what this question is asking. Can you explain it better? Yeah, I'll be glad to do that. Okay. Or what are you really looking for here? You know, that kind of thing. Now, here is an example. Here is a question I will not answer. Well, no, this one I will answer. Can you do number 7? My answer is yes, but that's all you're going to get. Okay. I'm not going to work a test question for you. But what I will work for you, any example you can find in the text, I'll be glad to work for you. Okay? That even includes the even ones, okay? Even or odds, even though they weren't a homework problem. And so find one like it in the book, and I'll work that for you in class, okay? Again, a reason to be here rather than depending on everything there. Okay, so make up work, try to get your test in a week. The second reason I give you a week, you always have a weekend in there. Because some of you may work outside of class, and you may not have any time to work on a test, to take on tests except on the weekend. So that's the 2 reasons I give you a whole week to do it. Now, I'm also a pushover. If you need more time, usually you can get it. But what I do not want to happen is you haven't turned in test 1, and I'm giving out test 2. Now, that to me is shooting yourself in the foot, because what if you made a bunch of mistakes on test 1? I don't know that, and you don't know that. And you go on working on test 2, and you're doing the same stupid mistakes. And no one can tell you, and you can't help yourself. So please get in test 1 before I give you test 2. So don't, I'll give you extra time if you need it, but don't have it out there past the time of the next test. Otherwise, you may be making the same mistake over and over again, and there goes your grade, down the tubes. Okay. Lateness policy, we've already talked about that. Oh, this is talking class. Now, as you just saw, I was a little late getting here because I got stopped in the hall 3 times, but also because I had to run down to my office because I was going from 8:30 to 2:30 with not a break. So I wanted to get at least a sip of something, and I ate a granola bar. I'm sorry about that. But with only 5 minutes, I may not be back. But I'll get here as soon as I can and try to keep that with me. Okay. Academic integrity. They put all this in here. They require us to put it there. Let me just say this. Plagiarism. Don't do it. Okay? Y'all know not to do that, right? Don't do it. And it gives all the details here. Cheating. Don't do it. Okay? Don't do it. If you need this course for some future course in engineering or whatever you're in, what good is it if you don't know how what's happening in the course? You got it off somebody else's paper. That's going to do you no good in the upper level course that you need to know how to do an integration or whatever. Okay? So don't do it. Okay? You can read all this at your own. Professional decorum. My word. Are there any more important things than this? Okay? If you sleep, I'm going to ask you, please don't snore, or at least loudly. You'll bother other students, okay? So when it gets to this stuff, if it's disruptive to the class, if it's bothering someone else, don't do it. If you're going to fall asleep if you don't have some caffeine, I prefer you drink something rather than not drink and then fall asleep and snore. Okay, so, yeah. These are long classes. If someone has an immediate need to go to the bathroom, you're not going to get anything out of sitting here in the class. You're not going to be following what we're doing. You're going to think about my immediate need to go to the bathroom. So go to the bathroom. So don't worry about this. And if someone says, hey, can we have a break now? I'm going to say yes, okay? I'll just about always, I may say, let me finish this slide, and then we'll do it. Yeah. So if we need a break, we'll take a break. So this to me is sort of high schoolish to me. I don't know. Maybe that's me. Anyway, just don't be bothering other people. Okay, course concerns. What if you feel like I'm not giving you a fair shake? That you think here's the way to hit it. Okay, first, come see me. We'll work it out. And if we can't work it out, then speak with the department chair. Whoops, that's me. Okay, so I'll be glad to talk with you again. Okay. No, and then we can go to the associate dean. We can go to the dean. We can go to the vice president of the president. We will find a solution, okay? So let us know. Don't harbor resentment and not let us know that you're not feel like you need to read that. There's a whole bunch of stuff on the website called that. Okay, this next one I don't want to make light of. Discrimination and harassment. Let me summarize this. We don't condone it and we don't tolerate it. Now, I've been here well more than 20 years. I can't remember, 21, 22, something like that. Almost in this room the whole time, not quite close. And so far, I have seen basically zero. Now, that doesn't mean for certain that it hasn't happened. It may have, but they sure haven't done it in front of me. So I want to ask you, if you see or even sense any type of discrimination, harassment, I like to put in here bullying or anything like this, please let us know, because we don't want it happening here, okay? I'll give you one example. It doesn't quite fall into this category, but it's similar enough that it fits. It was only my first, second, third year of teaching here. We used to be Western State Technical College, and we have a huge, really excellent automotive program here. GM, Toyota, Ford, General Automotive, Diesel, and on the other campus, auto body repair. I mean, we have a great automotive program. But back when we were just a technical college on this campus, we taught math for automotive technicians, okay, which is a very specialized course you do. So I had all the okay. And a lot of them were really sharp guys. Most of them were very young guys, right out of high school. And a few of them were very immature guys, okay? And a few gals too, but not really very many. And there was this one term, I had this kid in the class, and it was pretty obvious, and it was obvious for several of them, they really didn't care about general education courses. They wanted to work on cars. This kid, I thought that was the case. I found out later he didn't even want to work on cars. I think his dad said, you have to go to college. He said, okay, I'll be an auto mechanic. I think that's what it got down there. He had no interest in that either. But I didn't know that. All I knew was he wasn't very good at math. And then he showed up absent one day. And most of the time, the auto students were here every day because their scholarship or whatever depended on that. They had to be here. But I thought he might be sick or something. Well, then the next day he wasn't here again. So finally I said, well, where's this? I said, oh, didn't you hear? I said, no, what? So at lunch one day, he decided to walk across people's cars in the parking lot. And someone saw him, yanked him down, got him to the dean's office, and after a short but serious conversation, he was off campus, never to be seen again, okay? That's how I think of discrimination. That wasn't discrimination or harassment, but that's how we're going to give fair hearings, but it will be quick, it'll be fair, and it will be, you'll be given all your due process, but if it's been happening, the odds are you're going to be out of here, okay? Now, if it's false accusation, yeah, not that. But, so anyway, that's what. Now, Americans with Disability. I don't know if you've noticed it yet, I'm hard of hearing. And you may have also noticed this, I have a little bit of trouble seeing. I had a cataract fixed in this eye more than 9 years ago, but this one's acting up now. This is my near vision. This is my far vision, so driving is no problem, but reading has really become a problem. So the second Thursday, I think, in June, I have the appointment to have this one repaired, replaced, or whatever they call it. So anyway, that's going to happen. But so I'm sort of sensitive to disabilities. Oops, I'm going to put this up because I'm hard of hearing. I can't see well. I'm old and decrepit, you know, all that kind of stuff. So if you have any issues like that, please let us know. Now, don't tell me necessarily. We have professionals. Dr. Renee Herndon on this campus, Mrs. Janine McCoy-Jones on the Birmingham campus. Bring your information in to either one. They will let us know what we need to do to accommodate those disabilities, okay? And we'll do whatever it takes. I want you to have full opportunity to get done, to learn all the Cal 2 that you can possibly do. So let us know. Now, the course calendar is taken directly off the academic calendar that's found on the website, but I'll fill in the right dates. These are the ones from last spring. So these are incorrect, but I'll put in the right stuff from this term and get that corrected, okay? And then the last thing is your acknowledgement form. Once I have the syllabus corrected and not on Blackboard, you can either print this off and give it to me, or you can email it to me right off the website. So any questions now about the parts that we do know? Okay. All right. That done, I will close it down. No questions? Okay. My research paper thing didn't show up. Let me pull it up here. Click, nope, there it is, okay. Now, this is the information about the research paper. General instructions for it. All right, we'll try to make this as quickly as possible. Okay, you get to choose your topic. I'm not going to assign topics or anything else. You choose a topic. Any kind of topic within the scope of the course. You can choose to write about a person, a great mathematician, or a scientist, engineer, anyone who did anything to do with with calculus in general. It can be a theory. Fundamental theorem of calculus, central value theorem, mean value theorem, anything like that that you wanted to write on, if that's what interests you. A phenomenon that is explained or described using calculus, okay? An application. I really like to see application papers, okay? Someone give me a major. Anybody? Second? Which engineer?
Civil.
Civil, okay, civil engineering. Give me, or whatever engineering you are, whatever major you are, maybe even baseball. I don't know, okay? You can apply calculus to all sorts of things. Find that. I had a student, lived in McCullough, but was going to Jeff State, but I guess he decided, why am I driving past this campus here? Let me take my math here. So he's wound up doing it. Sat right back there, the last seat in that row right behind you. And right next to Jake, but he moved in. No, I'm sorry. But he was a pre-forestry major at Jeff State. He was going to go to Auburn and major in forestry. He was taking trig. And he wrote his paper on the use of trigonometry in forestry. And right off the top, you might think, yeah, that should take half a sentence. No. What some foresters do, they go out and give estimates on how much they're going to pay for this field of trees, right? So what they need to know is what the height of those trees are, how many board feet, they'll do excellent. Well, how do they figure the height? Do they tie the end of the tape down here, climb the tree, and say, oh, okay, it's 25 feet tall? I hope not. I don't want that forester, okay, around. What they do, they get a sextant, measure the angle from the base of the tree. They know their distance from the base of the tree. They measure that. That's easy to measure. Take the sextant, measure the angle, and then use trig, the tangent, to figure out the height of the tree up to the part they feel like is economically usable. They use trig all the time, okay? He wrote a paper on that. It may not have been the best paper I've ever, but it's one I appreciated because he was applying what we were studying in class to what he was going to be doing out in the field, okay? So any kind of application of it. Any other such topic about which you have an interest, and here's where I put in something new, just a few years ago. If you find an internet application, like a YouTube video or anything like that, that helps you understand something better in the class, and you want to write on that, fantastic, okay? I can easily imagine you can read the book, please read the book, okay? And it's sort of blah, blah, blah. And then you hear me talk about it, and boom, 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 you know, you can't even understand it worse. But then you find this application that suddenly makes it come to life to you. Oh, that's what they're talking about. If you want to write on that application, what was missing in the book or what you're hearing from me, I don't take all points for that, okay? How this brought it to life, how you compared it to other sites and you couldn't get anything out of them. What is it that made this good? If you could write a page or two on that, that would be a great paper. Then I'll also include that website in the Blackboard so other students can use it in the future. So that is another, it can be application or a demonstration to find useful to the class. Now what I'd like you to do either today or, as I said, next week is only Wednesday, is write down on a piece of paper your name and your at least first shot at what topic you want to write on. Okay? Now, that's a huge waste of paper, your name and your paper topic. If you want to write these next things on there, you can. This is not required. It has nothing to do with the research paper. But every now and then, and it's not very often, I get a panic knock on the door or someone gives me a phone call when I'm in the office and say, hey, thus and so's in your Cal 2 class. we need to get in touch with them right away. Something's come up, yeah, blah, 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 yeah. And the number in the system isn't working, okay? It may be that the number you put in your system, when they typed it, they transposed 2 digits and they don't know which 2 digits. Or it may be that that's a number that's been changed. Look, I was calling students about canceled classes for the last several days, and it felt like half the numbers were wrong. That's probably not quite true. But an awful lot of them, there was no way to leave a message. The mailbox is full. The mailbox hasn't been set up. Or someone answered and said, nope, I just got this phone 2 months ago. I don't know who had it before me. So, you know, that can happen. It has happened. It does happen. So if you want to give me your very best phone number, you can write that on a piece of paper. Because at the end of the term, that's going to be shredded. Okay? So don't worry about getting out into other hands or anything like that. We're only using it in case of an emergency. But if you don't want to give it to me, you don't have to give it to me. Now, if your very best phone number is a cell number, that's fine. That's probably preferable. It may be in the system you have your home number, and maybe the cell number is better. But if there's a chance that cell phone could die, the battery go bad, you leave it at home or in the car, or it gets run over by a transfer truck. I mean, anything could happen. If you have a good backup number, like Mama's landline or something like that, and you want to give me that, that's fine too. Now, a few others, like I said before, may work. And it may be they won't let you have your cell number at work, cell phone at work. But they will let you have an incoming call, especially in case of an emergency. If you want to give me that number, you can give me that. You can give me 0 numbers, 1 number, 2 numbers. I can't think of any reason to give me more than 3 numbers. But if you want to put that on that same piece of paper, you can. It has nothing to do with your paper topic, but it's just that in case you need it, someone needs it. So if you'll do that, either today or next Wednesday, turn that into. Now, you're going to need to find at least 1, but 2 or more are better, outside sources for your paper. This book is not an outside source, okay? Now, the book can be a great source of ideas, okay? In my first class, I ran across the name of a woman mathematician from early in the 20th century who had to, she was a brilliant mathematician, but she had to publish under her husband's name because no one would accept a paper from a woman. Shame, but it happened, you know. So, if something like that is of interest to you, then you can get the idea from this book, but your source has to be outside the book, okay? So, just keep that in mind, okay? The source can be other books, journals, articles, newspaper, magazine, whatever. Any materials you can find in the library, or, now this is dangerous here, any legitimate keyword here, source that you find on the internet. Because, as I tell most of our classes, during my lifetime, I don't think there's been any invention or thing discovered that's any greater than the internet. I mean, 1951, I don't think there was one. And in my lifetime, it's grown to something just unimaginable what you can access through that thing. The 2 major problems that I think of anyway. Number 1, at least, and probably way more than half the stuff on it is pure garbage, okay? Second problem, sometimes you can't tell which half it is, okay? So be careful with the internet. Make sure, if you have any doubt about the legitimacy, run it by me. If there's something I've never seen or heard anywhere else, I'll say, see if you can find something else backing this up, or just leave this alone and find something else. Or, nah, that's great, yeah, that's perfectly fine. See it all over the place, yeah, you can use that. Yeah. Most of the time, you'll probably find that. Okay, the textbook is not the outside source. It can be the source of ideas, but it can't be your source for your paper. Okay, it needs to be at least 1 word process page. Now, let me tell you what that means. You may choose to have some type of a header. That's fine. I don't care. I don't require it. But header, and then you skip a few lines, and you have your title, and you triple space, and you start typing right here. Well, what's 1 page of text? It's going to go to the bottom of this page, and then on the next piece of paper, it's going to start at the top and come down at least that far. That's the page of text. So you don't give me this little stuff here and they call that one page of text. It needs to be, it's going to be at least 2 pieces of paper, and the second page has got to come down at least as far as where you start from this one. Okay? At least 1 page of text. But I want it double spaced. This is single spaced. I want it double spaced. So that means you don't have to type as much. Okay? And I want standard font, 12 pixels per 12 point. I don't want it so tiny I can't read it. I have eye problems, remember? And I don't want it 26 point font that 3 words take up a page and you say you're through. That's not going to work either. So keep it something reasonable. And you can use any font as long as I can read it. I don't read Old English and hieroglyphics and that kind of stuff, so don't get cute with it. Keep it something nice and readable. Okay? Try to keep the paper less than 2 pages. That's a try. That's not a requirement. It's just I don't want it to be a huge burden to you. I just want you to get out of the book, into the real world, thinking about it, something of interest to you, report on it. Let me know that you can communicate well. Okay? Now, you will lose points if it's too short, if it's not that, at least 1 word process page, double space. Okay? There's no penalty for it being too long. Okay? No direct penalty anyway. I haven't had this out there often. I hate to go into this. But like I said, I've been here 20 some odd years. And I didn't do this the first few years, but sometime after I started going to SACS workshops and things like this, I found out they really were pushing writing across the curriculum. So that's when I started assigning these. And then I found out it was really a good idea to get people thinking outside the book, you know, or the box or whatever. And so I've been doing it for well more than 15 years, I'll put it that way, okay? And I've taught every term since I've started here. We used to be on quarters, now we're on semesters. That's 3 terms a year now, used to be 4. I'd be anywhere from 3 to 8, 9 classes a term, so a lot of classes. Most classes are average bigger than this one, so that's a lot of papers I've seen. I've only had this happen a few times, that someone decides to substitute quantity for quality. So they figure if I write a really long paper, he's going to give me a good grade. Well, let me dispel that notion right now, because when you turn in a paper, it's a 100-point paper. Then I start reading it, and if I find errors, you start losing points. Okay? So give me a good quality paper, you're not going to lose many points no matter how long or short it is. It just can't be shorter than the minimum. But if it's a really sloppy paper and you're just trying to replace your sloppiness with length, then the more I read, the more points you're losing. After a while, you pass the point of any benefit, and you're into negative territory. So please don't go there. Give me good paper. If you get so excited about the topic, you can't end it in 2 pages. Go on to the 3rd page. I don't care. I'm going to enjoy reading the paper that you're that fired up about. Okay? I just don't want it to be a huge burden. Just get it done. Now, you can use any format you want. Most English classes teach MLA, which is Modern Language Association format. A lot of science areas use APA, which is American Psychological Association. Just came out with an early format, and everybody said, hey, I can't beat this. We're going to use APA. So if you want to choose that, or if any of your professional organizations use a special format, you want to get used to writing in that, fine, do it. But I want you to be consistent, okay? If you start blocking paragraphs, block all your paragraphs, okay? I've actually seen some papers that some paragraphs will be blocked, then on the next page they indent, or on the same page they indent this one over here and the next one over here. I mean, that's just sloppiness. That's just not being consistent, okay? But I've also seen something like this. Up here they make a reference to a source, open parentheses, put the author's last name, comma, page number, close parentheses. Okay, if that's how you do your citations in your format, fine. But then later, they'll do another citation and put open parentheses, title of the article, comma, page number, or year of publication, or something else. And it's like, wait, it's the same type of a reference, but they're using different, well, that's because this book or journal or whatever here uses this format, so you use that one for this one, and then this one down here was a different format, and they used the format because you choose your format and be consistent through the paper. Now, I understand a book will have a different format from a journal article. Yeah, I understand that. That'll be obvious. but if it's the same type, it ought to be the same way. Okay. So anyway, be consistent. That's the key. Okay. Now, spelling, grammar, sentence structure, all those kinds of things that we count off any other paper, they count off here too, because what I want is a quality product. Okay. Imagine I'm the customer and you're writing up a quote for me. You know, if it's really sloppy misspelling and stuff, I'm going to say, you know, I may go to another company. Thank you very much for your quote there. Okay. So do good work. Okay. Guess what? Most of your word processing package has spell check on it. They just about everyone has grammar check nowadays. Okay. And you can do good proofreading. Do it. Okay. Now, content also matters. If you have writing about the mean value theorem and you mistake the mean value theorem, I'm going to pick up on that. I'm going to say, whoops, no, that's not the mean value theorem. You got this wrong. So content will also matter. Also, silly things like giving the date of a person's birth and date, and when you first introduce it, I have to do it. I have people do that to me. Over on page 2, they have them dying in a different year than it was there. It was a boring paper, but it wasn't that. No, So be consistent, okay? I've also had something, say, writing about Isaac Newton. I'll just make up something that he may have done in 1692, and they had it done in 1962. No, he was long dead by then. So be consistent. You know, proof. Make sure what you're saying is right. Okay? When is it due? Technically, the last day of class before final exams, not during final exams, the last day that we meet as a class and have a class. Okay? But I don't want you to put it off that long. I want you to get started on it as soon as possible and get it done as soon as possible. You'll never have more time to work on it than you will right now. Okay? In a few weeks, you're going to have more tests. Summer term is compact. It's got lots of stuff in it. You're going to have projects. You're going to have tests. You're going to have other papers. You'll have all sorts of things to do. Get started on it now and get it done early. If it comes in after the last day of class, you start losing points. Okay, if you turn it in during finals week, it's not a whole week, it's just a day or two, you're going to lose points. Okay, if it's not in by the end of the term, you get it in later, you'll be losing points. That's the stick. Okay, here's the carrot. If you get it in the month of May, and there's not much month of May left, but there's a little bit, you get 2 bonus points, just added to your score. Okay? Turn it in the month of June, 1 bonus point. Month of July, you just get your score. Okay? I don't think the month of August that'll be during finals week, so we can't go there. So I'll get this all corrected then, okay, before I put this on Blackboard. And one other thing that I require that most other places or things don't. When you submit your paper, please attach a single page from one of your sources. Or if you're referring to that website you went to that you got interesting, give me the link for that. Of course, you would need to do it anyway. But if you can't print a page out of a website, okay, a YouTube video or something like that. So just give me the link on that. But if you did get, if you had 3 sources, say, pick a source, any source, I don't care, one of your sources, and then pick a page, a single page from one of the sources. So if it's something you got off the internet, print me a single page from the source, attach it to your paper. If there's something out of the library, take it over to the copy machine, copy me 1 single page from that source, turn it in with your paper. Any questions on the research paper? Like I say, I've just got a couple of minor corrections to make here, and this will be out there on Blackboard. Any questions? All right, good deal. Okay. Finally, my locator card. This is from last summer, so things aren't quite the same, but they're close enough. I'm going to put them on. This summer we're starting at 8:30, not 8, so everything gets moved down here. I have first thing on Monday. So my office hours are 8 to 8:30, Monday through Thursday. First half hour, I'm in the office. Okay. And on Monday and Wednesday, I have at 8:30, Cal 1, 125. It goes until 11:25. So at 11:30, our class starts. Okay. And it goes until 2:25. And then after 2:30, I'm in the office, unless I pick up that calculator. And by the way, my name's still the same, my phone number in my office is still the same, my email is still the same. I'm still Matt Department, okay? Let me scroll down here a ways so you can see most of the page. Maybe not all of it. Okay. All right, so then from 2:30 until at least 6 o'clock, I'll be in the office on Monday and Wednesday, okay? Unless I pick up that Cal 3 class meeting. I'll find out that this evening. I'll let you know next Wednesday. Okay, on Tuesday and Thursday, in the office from 8 to 8:30. 8:30, differential equations class starts, and it goes until 10:45. So at 10:45, I'm in the office then for the rest of the day. Linear algebra didn't make this summer, my physical science didn't make this summer, and the physics didn't make this summer, so I'm bare bones scheduled for this summer. I've never had this many office hours before. So from 10:45 until 6. Unless we move the Cal 3 class to Tuesday and Thursday, then that will change. But for right now, 10:45 to 6, Tuesday and Thursday. Then on Friday, and this only pertains to this Friday, next Friday, and the first Friday in August, I'll be on the Birmingham West Campus Academic Building, B122, from 8 until 12. Okay, so those hours have changed a little bit. Any questions on my schedule? That will be out there under that second topic in the first group, instructor information. Any questions? I'll get that corrected. I'll get it on Blackboard. Okay, I think that finishes everything I've got visuals for, but there's one more thing we have to do, and that's talk about safety. There's nothing we're going to be doing in calculus that's going to be hazardous to your health, okay? That may be mental health, I don't know about that. So, but we have to think of overall things. 3 areas we have to think about safety-wise. Can anyone think of one of them? Jake, you've been in how many of my classes? Did I go through this every one? Anyone think of one? Safety issue. It's pretty day to day. Oh, weather emergency. Yeah, that can happen, can it? Or anybody living in Alabama, what was it, 2011 was it? Yeah. April, was it?
It was,
huh?
It was like right at the beginning of April.
Yeah. And weather issues can happen in Alabama, even in the summertime. I was just hearing on the news recently, just either this weekend or maybe since this weekend, Missouri or somewhere had a really major swath of tornadoes come through. So it can happen. What happens if we hear that weather alarm? What's the rule? Say again?
Beautiful. I get on the floor.
Okay. That is an idea, but I wouldn't get on this floor.
We go up to the hallway.
Yeah, okay. Hallways are better than this one. Why? Because of windows. Because it's strong wind. Even if it's not a tornado, severe thunderstorm can have such strong straight line wind, one of those limbs or maybe the whole tree can come right in. So I wouldn't get on this floor. Hallways are better, but what's better than hallways? Say again? Yes. Go low and interior. That's what you remember, low and interior. Where do you do that from here? Okay? And when I get away from the computer, it's not going to pick up sound as well. But you go out the door here, hang a left, then go down that little half line of stairs right there in that hallway. At the very bottom of that stairs, there's another stairway on your left. Go down one complete flight. When you get to the bottom there, go interior. That's as low as you can go in this building. And right there in front of you will be the restrooms. Actually, these are not bad places to be. Why? Because the walls are close together and you have lots of corners. The greatest strength in a building is in a corner. You have support on both sides. And other than that, close walls. That gives you good strength. So the restrooms aren't bad, except it may not be the best environment for a couple of hours. You may be stuck there. So you may not want to go to the restrooms. if you go down, actually on the first floor, there's another step or two down till you get to the very lowest level. And right there on your right is an office that is the academic dean's office. Now, most of the time she's not over here. She's on the other campus. Most of the time that's why. But occasionally she's here, or the associate dean's here, or maybe the guy who runs the summer enrichment program uses that office. If anyone's in there and they invite you in, again, it's a small space, close walls, and lots of corners. So it's not a bad place to be. Okay, here's the other thing. See this wall here? Now this is second floor. On the first floor it looks a lot like this, but this wall back here on the first floor, behind that is soil. It's not outside. That's soil. There's no windows to anything because the soil comes right up somewhere along that wall. So that is a very solid. So get as far back as you can. Interior, you're on the bottom floor. Next to that is a room down there. It's room 160. It's a developmental math classroom. And that's not bad. It's a big open area, so you don't like open spaces. As long as you can be that back wall would be great, because you've got lots of supports there. Corners may be even better, but anywhere in there is okay. Okay? Walls are better than out the open. So that's not bad. Then you go through a glass door, don't go through the door, open the door, okay, in the hallway there, and you're in the library area. The first room on your right there is a computer room. That's a smaller space. The walls are closer together, corners, and that back wall is against the wall. Again, a good idea. Right next to that is a reference room. That's where the atlases and those kinds of things are. Things you don't check out. That's not bad. Now, it does have shelving in there that if the weather was bad enough and shook the building, you might have some of that, but I don't think we'll have any of that. So that's not bad. Don't go any further in the library because then you're in exterior. You're in windows. Don't go any further into the library than that. Don't go to the outside because there you have windows. Okay? Now, one place I left off may be the place of choice. The problems with these interior rooms here, even though they have close walls, lots of corners, and this solid wall behind you, none of them have emergency lighting. And because in a weather emergency, there's a really good chance the power will go out. The hallways has emergency lighting. The walls are relatively close together, not many corners, so that you don't have that kind of support, but they're fairly close, and you do have emergency lighting. So for a long haul, that may be where you wind up. I know that several years ago we went to, in the spring, professional math meeting up at Athens State University, up in Athens, Alabama. And we got there, they had a few snacks and stuff, we got registered, everything. We got into the main speaker, the big dude they had brought in to speak, and he was a really good speaker. He got maybe 15 minutes into his talk. It looked like it was going to be quite entertaining, and this weather sirens went off, and we had to stop the meeting, actually go across the road, which wasn't a good idea because that building didn't have a below ground floor, but the building across the street did. Went across the street into the basement, and we sat in the hallway for about an hour or two waiting for the weather emergency to pass. Nothing bad happened on campus, but it was close enough we did. That was our meeting. They sent us home because it was unstable weather the rest of the day. So that was quite a nice trip for 15 minutes of a good talk. Okay, but hallways are usually not a bad place to be. And also when you go down, you stay together in a group because I'm going to be the last one down. Because if any of you happen to be a little bit slower than others, maybe you twisted an ankle over the weekend and you're on crutches or something like that, I'm going to be making sure that the last person out gets all the way down. And then when I get there, I'm going to have my roll book and we're going to take roll. And if anyone's missing, that means myself or someone else has to go up into a hazardous area where there's glass and everything trying to find you just because you went home to let the dog out. No. Leave the dog alone. The dog's safer inside than you on the road. So don't take off and go. Go down, stay in a group. Once we called roll, accounted for everybody, then if you want to mix and mingle with others in other classes, that's fine. But you don't leave. The worst place to be in the weather emergency is on the road. Okay. So that's one type of safety issue. Can anyone think of a second type? Second?
School
Okay. Yeah, that's the one I usually say to the left. We'll hit it now. Didn't used to ever even think about it, but nowadays you have to. At computer. What if y'all hear the pop, pop, pop? And I say y'all because I'm hard of hearing. You'll hear it before I will. If you hear something that even remotely sounds like gunfire, let me know. Okay? What do we do? What's the procedure? Second, turn off the lights. Excellent. What else? I'm sorry?
How do you set back wall?
Yeah, we like.
How do you set back wall?
Okay, excellent. Perfect. We get out of sight of that window of the door. Okay? This is the safest place to be. You can't see us, the light's off, can't hear us because we're not making any noise whatsoever. If he's trying to fire through that concrete wall, he's going to have more repercussions on him than yes on us. Okay? Yeah, this is where we go. But before we do that, here's second. Lock the door. Excellent. The trouble is there's no way to lock this door from the inside. Okay? I open the door. There's no way to lock it here. I have to literally go into the hallway, find my key, in jittering hands because there's gunfire behind me, and lock the door from the outside, and you better not pull it too, okay? So let me get back in before you pull it too. Okay, and we get in. Y'all meanwhile get over here. Now the first bit of gunfire, what does somebody do?
Yeah.
Call 911.
Yes, okay. Actually, I would say
I think when we have to be quiet, we don't want to scream.
okay.
That's gonna bring them here.
Yes, no screaming.
When I say yeah, I'm like,
and
let you know it's gunfire. Like I heard it's gunfire. So I gotta let you know. And then that's when I hear y'all.
yeah, exactly. That's why the first sound of it, that's when we call. Then you turn your phones off. You don't want mama calling, hey, I heard there was gunfire out there. Are you okay? Well, you just got him into the room, Bob. So don't do that. Turn those phones off once someone's called 911. Now, actually, better than 911 is campus police. Now, they probably already know about it, but on the door I come in, I think every door, there's a thing posted on the door with campus police phone numbers. One for the Bessemer campus, one for Birmingham campus. Get that Bessemer campus phone. Put it on speed dial on your telephone, so if you need it, you can dial it immediately. If you don't have that, then 911 is next best. But that is better because that's the phone that the duty, even on weekend rent-a-cop, has got that on his belt, so somebody is going to be able to answer. It's not in somebody's office, maybe someone went to the bathroom or something. It's on somebody's belt, so they will be able to do it. So call that number or 911. Okay, so I go out, lock the door, we pull it to you, y'all get behind there, phones off, lights off. We have a problem, don't we, Houston? There's another classroom right over there. I don't have a key to that classroom. Okay? Now, what we'll do, we'll get those students, because there is a class there, come and join us here. I will go over and make sure that door is closed. Now, if it's locked from the outside, fantastic. But if it's unlocked, which it may be, then this door does have a button, but it locks from the inside, not from the outside. So don't lock this door, okay? It locks us in, but it doesn't lock him out. Now this door has a deadbolt. I don't have a key to it.
Jesus. Whoever decided this specific campus should still be open without updating any of the doors, not make a good decision.
Say that again, I didn't hear all that.
Whoever decided that this campus should stay open without updating all the doors made a bad decision.
Hey, I can at least lock this door. Remember that physics class I used to have on Birmingham East Campus didn't make this summer? Those doors have no locks at all. They open to the outside, so you can't block them from the inside. There is no security in that building at all. At least this one I can lock the door. Okay? But what I do here, that next door there, is a lot like this one. When you press the button there, it locks from the outside, not from the inside. So that's the one that we lock. Okay? But don't lock it while I'm closing the other door. We get those folks in here, they're leaving now, but if they were there, we get them in here. Then we close this door because, you see, there's glass there. We don't want them seeing through. So we'll close this door with that block, and then we get as quiet as possible. Okay? And that's how we do it until we're absolutely sure all's clear. Okay, now sure, I bet you can think, just like you're thinking, these buildings were not designed for active shooters. Back then, nobody would have even thought of an active shooter. In fact, 5 years ago, I probably wouldn't have thought of an active shooter. It's only been recently. This building's more than 5 years old, by the way. Okay, so it wasn't designed. We do the best we can. Now, if he manages to get in that door, break through the glass of that and get in here, open it up since we can't lock it, and makes his way in here, you don't be the hero. You are our future, okay? Most of my life is back here behind me. So if anything's going to happen, let me take care of it, okay? Push me out there if you need to. But I was in the military. I've had not major training like this, but at least I've heard a few things and know a few things. So don't you be the hero. But hopefully it'll never come to that. Okay, so there's two of the three. Weather emergency, active shooter emergency. What's the other safety issue you have to think about? Fire, exactly, or something else like a chemical spill in the building. Okay, the difference here, you want to get out of the building. Well, let's get worst case scenario first. What if the fire initiates in this room? Say my computer blows up and sets the paper in the desk on fire. What do we do? Anybody? Say again? Okay, get out of the room and let the building burn down and all these other poor people die smoking. Oh, wait, yeah, we need to do something before we go out of the room, don't we? What's that?
Pull a fire alarm?
Pull a fire alarm. Excellent idea. Where's the closest fire alarm?
Possibly in the hallway.
Now, again, this is embarrassing. I can hear you saying it now, Ricky, but this old part of the building, everything you see here was built before fire alarms were
This is great.
This is great, isn't it? Okay? There's not a fire alarm anywhere in sight in this hallway or that hallway. But if you go out the door here, take a left, go down that half flight of stairs, this time go all the way to this corridor here, hang a right, that's the one that goes to financial aid and that kind of place. That's the new part of the building. It's not shown here because this is first floor, that's second floor. But you go through here, you're on the first floor, and there's fire alarms right in sight, but to your left and to your right there. So I suggest two people go down to do, in case one falls down the stairs, the other one can still get down there and pull the fire alarm. Okay? Buddy system type thing. So that's one thing we do. What's another thing we do? Yes, either campus police would be first choice or 911 second to let them know we have a fire in the building. Okay? So we sit someone down to do the fire alarm. Somebody is called, and we're going to be ready to, and some of you will be getting up already and ready to go. What's another thing we need to do, though? You want everything to burn up in here? Second? Fire extinguisher. Where's the closest fire extinguisher? Okay. This one you won't be so displeased on because you got to have the door here and 5 feet from where I'm standing, right there. You can't get much closer. Okay. Someone that I know you guys, maybe you gals too, back in grammar school or sometime, that you need to break that glass. You know, it says, do not break the glass, right? You know. Oh, well, this is your chance. You get to break the glass, get the fire extinguisher. If you don't know how to operate it, I've been trained on that. I'll operate it while y'all are getting out of here, right? Sorry. Making too much noise, close the door. Okay, sorry. Okay, so anyway, get the fire extinguisher, we'll do that. The rest of you, meanwhile, are heading out. So what you do is same as before, the quickest way out of the building, go out the door here, hang the left, go down the half flight of stairs, hang another left, go down that flight. This time rather than going in, you go out. Okay? Where do you go out? They used to say go 75 feet away from the building, which is a good idea because if there is an explosion, the glass is going out. So you want to get well away from the building. However, now they're saying, we're right here in this corner classroom, this A building here. We go out that exit there, okay, the one right by the stairwell. out the building and go down to that parking lot right over there between this building and Ethel Hall. Stay together in a group. Don't say, hey, the building's on fire, no more class today, I'm out of here. No, don't do that. Because I'm with the last person out of here, making sure that everything's done, taking my roll book, I call roll. If you're missing, the only assumption we can make is you're back in the burning building. And myself or some fire emergency personnel have to go into a burning building, risking their life and health, looking for you when you've taken out and gone home. Don't do it. Stay there in a group until we've called roll and we've got word. All's clear. Class dismissed. All's clear. We're going to a different building. All clear. It really was a false alarm. Whatever. We find out what's going on. Then we decide what to do from there. All right. Any questions on emergency situations? Safety. All right.
I have a question.
Yes.
Not on safety.
Okay, fine.
Okay. So, didn't know like y'all schedule work like that. Like I had to choose like on one class time for everything, right? So I have a question.
Yeah.
If I leave class at 1:30, I'm gonna be here every time class is here. I'm gonna be here on time. But if I leave at 1:30 to go to work because I have class every day of the week here, and can't work on Tuesday, Thursdays, is that fine?
Okay. Again, that would be just about anything. I record all the classes that I can.
But I'm gonna be here for 2 hours. I'm gonna be here till 1:30. You're adults. Life gets in the way. Do whatever you need to do, but just letting you know, I record everything, and that way you can pick it up at home later. Once it gets on YouTube and I get it on the playlist, you can go and listen to anything you may have missed. So yeah, same thing as if you had to be out of town. You had 2 weeks active duty training for, reserves or something like that. That's why I record everything. So if you have to be gone, you can. Say again?
I was gonna say I'm probably gonna be late on Monday and Wednesday. I got class down in UA.
Oh, what? Yeah.
From 8.
Yeah, that happens. Like I said, life gets in the way sometimes. Anything you do miss, you can get it in the first part of the YouTube video. Yeah.
I was a class late with like 1% says homework and stuff.
Okay. The grade in here is based on your research paper and your chapter test. That's it. Homework is for your benefit, so you'll know how to work the problems. And I highly recommend you do that because those problems you do for homework are going to be very similar to what you see on the test. And if you do them and keep up with it as you're doing, you're learning the material. When it's test time, you're going to find the tests are not as bad as you thought they might be. And you can get them done fairly quickly, get them in a week. If you don't do the homework, you're going to be struggling on the test for maybe more than a week and not really sure what you're doing. And it's going to be, so do the homework. That's for your benefit, not mine, yours. And if you have any questions, if you can't do the homework, and you go to the videos, you go to the calchat.com and all that, and you still can't do it, see me. I mean, come to catch me. I got lots of office hours, especially on Tuesday, Thursday, but also right after this class, I got office hours. We can go over homework then too. So please do the homework. That's for your benefit. Yeah.
Is the homework going to be through the book?
Okay. That's why I don't. Okay. Part of the reason I don't grade on homework, because if you're using your book from your school and someone else using it, they're going to be different homework, and I can't say which one's easier or harder, so I don't want to grade. That would be really hard to do. It's for your benefit, and like I said, most of the books are covering the same material. The homework may be different, but do the homework in that text that you're using. Yeah. So no, if you have this book, if you decided to get it, I'm assigning it through here. You do whatever is equivalent in your book. If you're using a different book. Yes?
And to get the 4 bonus points on the research paper, it has to be
Say that one more time.
To get the bonus points on the research paper, it has to be turned in by the end of May or the next month.
Well, 2 points for the end of May, 1 point for the end of June. By the end of June. Or any time in June. Yeah. By the end of June. Yeah. So, those are the bonus points. Good questions. Any others? Okay. Y'all been sitting, I've been able to move around. Do y'all need a rest break, coat break, bladder break, any kind of break? Okay, let's try to keep it less than 5 minutes, and we'll come back and get into actual calculus, okay? And we'll start, since it sounds like everybody's pretty much at the same place, we'll start whatever chapter that was. 7, I believe it was, beginning of chapter 7.
time by myself. I have the book from UAB from Carolina.
Right.
And
Okay.
I'll meet with you probably this Friday to see if it's okay.
Say this again.
I said I'll meet with you probably this Friday to see if the book is okay.
Okay,
And
yeah,
I asked
and
for
we'll
UAB.
go over and see what sections match
Okay.
these. Okay, good deal.
So I'm about to go to my brother's graduation.
Oh,
Yes, sir.
okay, well, congratulations to
Yes,
him.
sir. I was going to ask you about the STEM program.
Uh-huh.
Is it still any way I can still apply for a position or anything?
Okay. The STEM program is basically run mostly on the Birmingham West campus.
Yes, sir.
Okay, do you know Dr. Briggs there?
Yeah.
You don't, okay. Is there any way you could be there Friday?
Yes, sir.
Okay, I'll be on the Birmingham campus Friday. I can't swear that Dr. Briggs will be there, but the odds are he will. But if not, someone will be there who probably can answer questions. I'll try to hook you up with the people there. Are you at all familiar with the Birmingham campus?
I just went to it this past week to register or whatever, so that's
Okay.
okay.
I forgot. I was going to put this on pause. Not that I'm... When we do take a break, someone always remind me, did you start the recorder back? But once it comes up, if you see this going on in the corner, this yellow circle with two vertical lines and a number increasing here, the recorder's on. If you see a bar across there saying something else, then it's not on. Okay, so we are recording now. We'll go from current slide. And this is where I understood all of you were coming from, right? So chapter 7 is where we begin. Applications of integration. Okay? 7.1 will be talking about determining the area of a region between two curves. Okay? Probably the primary fundamental use of integration. Okay? The objectives here: find the area of a region between two curves using integration. Find the area of a region between intersecting curves using integration. And describe the integration as an accumulation process, which is sort of kind of a nebulous type thing, but we'll hit it. So, with a few modifications, now what that's talking about, this is assuming that you have just finished. Chapter 6 was differential equations, so that was sort of a strange one in there. Chapter 5 was the logarithm and exponential functions and some other functions there, which are sort of thrown in. So chapter 4, which is when you hit integration the first time, and you did definite integrals, indefinite integrals, you talked about areas, you talked about Riemann sums, all that fun stuff, remember? Taking limits, all that kind of stuff. Okay, so that's what it's talking about. With a few modifications, you can extend the application of definite integrals, which we did in chapter 4, from the area of a region under a curve to the area of a region between two curves. Okay? Now remember before, when we were talking about it, let's imagine this g function is not there, and we were talking about the area under a curve. Remember we said the curve always has to be greater than 0. Because if you're talking about here, that's a negative area, and that's sort of weird to think about. So we usually kept the areas up here. Okay? And we're talking about the area between the curve and the x-axis. Well, now we're just going to introduce another bottom for it. Another curve down here, g, between two curves. So let's consider these two functions, f, like this, and g, like that, okay, that are continuous on an interval between a and b. F is completely continuous there, g is completely continuous. Out here, they can be discontinuities, they can be any kind of weird things going on. No sweat there, as long as they're continuous between a and b, x equals a and b. Also, the graphs of both f and g lie, now they're saying they lie above the x-axis. Later we'll find out that's not necessary, but for now we will. They're both above the x-axis. Okay? The graph of g has to always be below the graph of f between a and b. Now obviously it's not out here, but that's outside b. It looks like it wouldn't be over here, but that's before you get to a. So at least between a and b, that g is always below f. Okay? Those are the requirements. And we have them all being above the x-axis. Nothing negative here. Don't get negative somewhere, but we're not interested in that. Okay, so this is the setup. So how do we do the area between those two curves? Well, geometrically, think of it in this way. This is what you're interested in, the area between A and B, less than F but greater than G. Okay? That's what you're interested in. Well, where is that coming from? Well, if we took F itself, forget G now, like I was saying before, and just do the integral under F between A and B, that's all done by a definite integral. Remember this one? Whatever was equivalent to our chapter 4 when you did definite integrals. That's what you're measuring, the area between a curve. Now, if you're having trouble remembering that, think of it this way. The f of x is the height of, say, a little, just imagine your little rectangles here. Remember the good old Riemann sums? Those little rectangles here, okay? The height of the rectangle is your f of x. The width of the rectangle is your dx, the delta x, okay? And then you're summing those or integrating those between A and B. So this is the area under the curve of F between A and B. Well, similarly, now forget about F and put G in the picture here. This is the area under G. And this is why it was necessary for us to keep G positive above the x-axis. Then this is the area under G, right? Same deal. Here's your G of x, here's your dx. So this is an integral from A to B of G of x. Well, then subtract this from that, and what do you have? This area right here. This part here is that part. This is the entire part. This is the part that's the difference between this and that. So it goes to show, or at least geometrically, it looks like the area between the two curves is the area under F minus the area under G. So area of F minus G. But think of it this way. Think of your little dx's here again, remember? And then the height here is F minus G, right? And the width, the height is F minus G, there it is, and the width is dx, there it is, integrate from A to B. So, yeah, it's just a simple extension of this, and that geometrically shows, yeah, that looks like perfect sense. And it is. Okay? Now, to verify the reasonableness of the result shown in that figure, you can partition, and this is what I just said. Just think of any old partition here, a delta x anywhere here, x of I between A and B, then the f of x of I minus g of f of I, that's the length of that rectangle, your dx is the width of the rectangle, and sure enough, that would then, with the Riemann sum and everything else, come the integral of f of x minus g of x. The upper one minus the lower one, that's the width, the height, the width would be dx, sum that from A to B. So yeah, that certainly seems reasonable. Okay? Take the limit is what takes the Riemann sum, the summation, to an integral. Okay, the area of that representation represented a rectangle, delta a sub I, that one little thin one there, the height, which is f minus g, times the width, which is delta x. And by adding all those in rectangles together, and then take the limit as n approaches infinity, meaning the delta x is going to 0, that gives us this limit. That limit becomes this integral. Okay? Why they write it so many different ways, because f and g are continuous. That's required on A to B. Okay. Yeah. That shows up here. And f minus g is also continuous on A to B. Then the limit does exist, so the area is given by that definite integral. So do you have to go back through all these summations every time? No. Just use the results. Think through, that's what you're dealing with, but that's exactly it. So the area of a region between two curves If f and g are both continuous, remember that was required, on the closed interval a to b, fine, and g is always less than or equal to f for every x in that interval a to b. You can't have some where g is greater and some where f is less. You can't have that in that interval a to b. They all have to be this way. Then the area of the region bounded by the graphs of f and g and the vertical lines of x equal a and x equal b is exactly that interval. Integral from a to b, f of x minus g of x dx. Now, if for some reason it was easier to do the integral from a to b of f of x minus the integral of f g of x from a to b dx, if it's easier to do that way, then it's fine to. Okay. But one thing I wanted to point out to you here, they left off something here they mentioned before. They said before that g had to be above 0. And they even said f had to be above 0. But when you're taking the difference, okay, what if you had the same thing but they were down here? It still works, as long as f is greater than g. Or f was here and g was here. It still works. So the requirement they both be greater than 0, the only reason we have that is so that this area minus this area is equal to that area, okay? We had to have that because otherwise we'd be negative. Now that we've just got the difference between two curves, it doesn't matter where they are in the coordinate plane as long as f is greater than g. So they didn't mention that, but that's inherent here. So we no longer require that f be greater than 0 or that g be greater than 0. All we require is that f be greater than g, greater than or equal to, and for every x in the interval. Okay. So in this figure, the graphs of f and g are shown above. This is what I was just saying. However, it's not necessary. Okay. You can take the same thing, move it down here, 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 anywhere you want to, and it still works. The same integrand, f minus g, as long as f is always greater than g between a and b, it works. They can be used as long as f and g are continuous and that g is less than or equal to f for all the x's in that interval. Now, the equal sign here means they could do something like this. F is greater than g, they're equal to, but as long as f stays greater than or equal to g, it still works. F just can't get beneath g. Then you have some negative areas there and they don't work anymore. So that's summarized here. This is what I was just saying. Here, f is always above the x-axis, but g in that region is always below. Here, f and g are always below, but you see it's exactly the same area between the two. So as long as f is greater than or equal to g, this will work. Okay, no matter where they are on the coordinate plane. Okay. Representative rectangles are used throughout this chapter in various applications of integration. Never a bad idea to think in terms of those. The vertical rectangle of width delta x implies integration with respect to x. But sometimes we'll do horizontal rectangles of delta y, and then it's your g of y minus f of y minus g of y would be the length of it. Okay? And that implies integration with respect to y. So whatever your delta is, that's what you're integrating. So let's do one. Okay? Now, I guess everything we've done so far, for some reason, there it goes. I've been doing all talking and pointing. Now you'll see. This computer is a tablet computer. I have an ionizing pen. Everything I write on the screen, if it's projected, that's what gets stored. My arm waving doesn't get stored. What shows up on the screen does. So find the area of the region bounded by the graphs of y is equal to x squared plus 2. Let's do that one first. Okay? Let's read the whole thing first. That's a good idea. Y is equal to negative x. X equals 0, x equals 1. Okay? So I'm going to put the y-axis here. I'm going to put the x-axis here because I'm not sure where it should go. I know that I don't need anything left of 0 or right of 1. So let's do a pretty big interval here. Let's do this as 1 here. Okay? Now, y is equal to x squared plus 2. What's that going to look like? Y is equal to x squared plus 2. Give me a point on y is equal to x squared plus 2. Between 0 and 1. X value. 0. When x equals 0, what's your y? 2. Okay, my y scale is not going to be quite right. Not the same as x. So there's y is equal to 2. And when x is equal to 1, what is your y going to be? 3. I didn't really botch this up, didn't I? Okay, so here you're there. Okay, now what is the basic shape of this thing? Parabola. What's your vertex for that parabola? 0, 2. So this is where it begins. I wish I had drawn this lower down. So this is what it looks like, something like that. My drawing's not very good. Okay, let's do the second part. Y is equal to negative x. What would that be? Give me a point there. 0, 0, that will be 1, and another one would be 1 minus 1. Okay, so there's that one. Obviously, I'm not drawn to scale between here. So that's a line that goes like this. That's a straight line, not a parabola. Mine's supposed to be straight. It has a negative slope, negative 1. So we're doing the area between here and here. Okay, so we have some of the graph above, some of it below. So think of this as your little rectangles here. Which is your upper graph? X squared plus 2. So this will be the integral from where to where? From 0 to 1. We're doing dx's here because we've got thicknesses of dx. See, there's your dx there, or delta x if you prefer that. Okay, and what's your difference? What's your upper function? X squared plus 2 minus a minus x, which is plus x. Right? That's a little awkward looking, so I'm going to rearrange it slightly. Integral from 0 to 1 of x squared plus x plus 2 dx. How do we do that definite integral? Remember what the antiderivative of x squared is? X cubed over 3. Excellent. Plus antiderivative of x, x squared over 2, plus antiderivative of 2, 2x. And we evaluate that from 0 to 1. Okay. Someone do the 1 for me. Second? Anybody? Oh, it's hard to do, right? When you plug in 1 for x, what does that give you? You don't need a calculator. 1 over 3 plus 1 over 2 plus 2, right? I'll do the 0 part. 0. Okay, done. All right. See, I'll do the hard part for you. You can only do these for you. Plug in 0, you get all zeros. So this will be, if I'm not mistaken, that's 3, 6 plus 2, 6 is 5, 6. That would be 2 and 5, 6. If you leave it in that form. I sure hope I got it. Oh, they leave it as 17.6. Either answer is fine, folks, okay? Now let me do a quick timeout here. Remember when I was talking about the Cengage Unlimited and your ebooks and all that kind of stuff? I'm almost certain they require me to get a code for you. Now you can use that, if you go that route, you can use that for the first so many weeks, I don't remember how many it is, without me giving you a code, so you can go on and get started with it. You'll need that pen off your receipt if you go that route, okay? But what I also have to do, they require me to put some homework exercises, in quotes, out there. I have to give things. So I just give them, give problems. And they usually even pick them out, okay? Now, those problems may be similar to this. They're probably not exactly like in the book, but I don't know, Jake, tell me if this is true for y'all too. I had a bunch of baseball players in my pre-calculus algebra class in the spring, and several of them told me they use it's called WebAssign. Do you use it too?
No.
Okay. But they used it a lot, and they said it really helped them. I don't ever make assignments. They'll say that I've made those assignments out there, but if that's beneficial to you, then by all means use it. But you can only do it if you do the 119 or buy the book from the bookstore and get the codes and everything. If you're using your home book, you're stuck with that. But if you do want to, I just want to let you know, I'd never had students tell me they really found them all that useful. But the reason I came up with that is I wrote the answer this way, and I saw in the book it was that way. And this is what triggered it in my mind, because in these computerized packages like WebAssign and others, they're looking for one and only one answer. And they'll tell you you got it wrong and you had it perfectly right. And that, to me, is nothing but frustration. Especially if you're sort of new to it, you're not certain about it. Yeah, I can look at this. I know that's going to be the same answer. I say, oh, they just want it in a different form. But you see, if I didn't know that's the answer they're looking for, I may have think, oh, did I subtract right? Was that supposed to be a minus? I don't know where I made my mistake. I didn't make a mistake because the answer's right. Only when I see the answer, I say, oh yeah, well that's just a different form. So that's, to me, the disadvantage of those packages. They can sometimes lead to frustration. But if you try all the possible ways of doing it and finally say, okay, that's all they're looking for is a different way. But sometimes that's more frustrating than the other. So I was going to say you can use those packages, but be aware that's a flaw in the ointment, I think. Okay. Any questions on that? All right. That's how I did it with my ugly drawing. Let's see how they do it with maybe a little bit neater. Oh, look at that. Isn't that pretty? Okay. So they draw the curves, and a lot of these you really have to. I hate having to draw curves. But that's a parabola with the vertex at 0, 2. Okay, we saw that. You're only interested from 0 to 1, and that's going to be when y is equal to 3. But down here we have the line that goes through the origin with a slope of -1, and so that's that line here. And then that's your representative rectangle, f minus g. But g is a negative number, so minus and minus makes it plus. They haven't gotten that far yet, but that will happen. And you're only integrating from 0 to 1. So, there's your, if you want to go through this, your delta A for that little rectangle would be your f at x of I minus g at x of I times delta x of I. And that would be, in general, x squared minus 2, x squared plus 2, that's your f, minus the minus x, because the first minus is because you're a difference, and the second minus is because that's your function. And that gives you plus. And they wrote it the same way we did. But then they thought they would do it. They didn't rearrange the order here, but they integrated it as if they had. So don't think these steps don't have something in between. Okay. Same thing we got. Y'all gave me. And that's 1/3 plus 1/2 plus 2, which is 17/6, often known as 2 5/6. Good deal. Any questions? Pretty straightforward. All right. That was example 1. We move next, and this, if anyone's following the book, on page 446, the area of a region between two intersecting curves. This was the second objective here. Okay. Now, I'll warn you now, I'll get carried away. So if y'all want to leave on time, someone just keep up and let me know, hey, time's up. But you don't have to be too focused on it. I don't have anything else to do today, so if you don't, we'll just keep going. Okay. In example 1, the graphs of f of x equal x squared plus 2 and g of x minus x do not intersect anywhere, okay? If you go back and look at that, yuck. What does that mean? Yeah. They're never going to intersect. This is going to keep going like this is like that. Never the twain to meet, okay? So you have to have some limits on it here. But what if you say this curve was flipped over like that, okay? Then you would have a point of intersection here and here, and if you wanted to know that, f of x is still greater than g of x, equal at the points of intersection, so don't go beyond that, but that's what we're talking about there, okay? So those do not intersect, so the values of a and b have to be given explicitly. A more common problem involves the area of a region bounded by two intersecting graphs where the values of a and b must be calculated. They don't tell you what those limits are, okay? Now, you may have some that they intersect, but you still want to stay inside the intersection. Then they'll give you those. All right, so here's example 2. Find the area of the region bounded by the graphs of, oh boy, okay? Not quite what I described, but awfully close to it. This time I'm going to be a little safer and draw it in the middle of the page. And we'll go from there. So let's do our f of x first. Give me a point on f of x. Oh, let me tick off a few things here. 1, 2, 1, 2, 1, 2, 1, 2. I'll do more if we need them. Give me a point on f. Okay, 0, 2. I thought that's right. See, a point is always an ordered pair. 0, 2, right? Next. We're just doing f now. Give me another one. 0, 1? I don't think that'll work. Plug in a 0 for x, you still get 2. 1, 1. All right, that will work. 1, 1. That works. So let's plug in 1 for x, and you get that. Give me another. Negative 1, 1 will work. And let's just pretend we had, let's see, where we go. Yeah, we can do. What happens if you plug in x equal 2? It'll be 2, negative 2. Is that what you said? And negative 2, negative 2. So I'm hoping that this will cover everything we need. There is your f function. Okay? Parentheses. Ah! Okay. I don't draw very nice graphs. Okay, there's f of x equal 2 minus x squared. G of x. Oh, that's hard, isn't it? What would be some points there? Second?
Identity function. 1, 1, 2, 2.
All right. It's the identity function 1, 0, 0, 1, 1, 2, 2. That's outside. Negative 1, negative 1, and negative 2, negative 2. So that looks like a straight line, if I could draw a straight line, of slope 1. Ha! Here we have the intersection graphs, and we have identified the 2 points of intersection. Now, we did that graphically. Generally, I don't like doing it graphically because you see my graphs are pretty ugly. So how could we have determined those points of intersection algebraically? What must be true about them? So do them this way. Find the points where f of x equals g of x. And those will be your points of intersection. That's where 2 minus x squared is equal to x. Right? There's f, there's g. Now what do we do with that? What would you do with that to solve it? Any hint will help. Do what? Okay, move what to the other side? Okay, you could do that. And it's a good idea. It's absolutely correct. But what I was going through is I like to always have my leading coefficient positive. I'm just picky that way. So since this is negative here, let's move it to the other side. Let's subtract 2 and add x squared. And that would give us what on this side? The left-hand side. A 0, which I like. And over here, I'm going to rearrange the order. What would that be? X squared plus x minus 2. Now, what would you do with that? Factor it. Okay. If it's factorable, we don't know that it is. If it's not, we'll use quadratic formula. And will that factor? I know it's going to be an x and an x. Sorry, that's on the line here. Now, you may do your factoring just like that. I like to, as a teacher, I guess. So I said, well, what's the only possible factorization of x squared? X times x. Then I go to the last term and look at the sign. The product has to be negative. What does that tell you about these two signs? They're different. So one's positive and one's negative. It doesn't matter which one you put where. In this case, some cases it would. Okay? And then you need two numbers that multiply to be a minus 2, or multiply to be 2, but their difference, because these are different signs, have to be a 1. What would they have to be? Multiply to be a 2, but difference of 1. Just the number part. 2 and 1. And which one gets to win the plus sign and which one the minus sign? 2 positive, 1 negative. I think that's it. Check it and see. FOIL it. X squared minus x plus 2x. That would be plus x minus 2. Yes, that works. So this will be at x equal minus 2 and at x equal plus 1. When you set each of those equal to 0, that's what you get. Here's the minus 2. Here's the plus 1. Yeah, those are our points of intersection. So if you don't like graphing, which basically I don't most of the time, then you can find it algebraically. Set the two functions equal to each other. Find the values. Now, at some point I have to graph anyway just to see which way this is oriented and which way it's going so I know which function's on top, but I don't have to be as precise about it. I can be sloppy. And I like being sloppy, okay? So, what would you do from here then? What's it asking for? Find the area of the region bounded by the graphs. Well, we know first the limits. There's no place else where they're bounded. Here, this goes infinitely small this way, that way. They're between those meet, and these are going in opposite directions. They don't. The only place they have in common is right here. So how do we find the area in there? The integral, perfect answer. From negative 2 to 1, excellent. Say again? 2 minus x squared minus x. Is that what I heard? Okay. dx. Looks good to me. You know, I don't care about whether they're not in order or not. We'll still work. So let's do it. What's the antiderivative of 2? 2x minus, what's the antiderivative of x squared? X cubed over 3, and the antiderivative of x squared over 2. Okay? Evaluate that from minus 2 to 1. I would say I'll do the 1, but I want y'all to do the 1. What would that be? Second? Did I hear a 2? I wish I'd have done the 1. Help me. Minus 1/3 minus 1/2. Perfect. Now, what about that minus 2? Okay. First, we're going to have to be subtracting, remember? Okay. So let's subtract. When you put a minus 2 in for x, that would be a... Second?
Wait, what was your question?
Did I hear negative 4? Yeah. Okay. What I'm going to do is, I like to do it your way, but I'm going to do it this way. There'll be a minus 4. Plug a minus 2 in for that one, and what do you get? Okay, yeah. You know what? The reason we have plus or minus numbers, right? The whole purpose is to trip you up and make you make errors, right? It's the whole reason we have them, but yeah, that's why they're in there. So this, if you have the parentheses out there, this will be minus a, what did you say the value was? 8/3. And minus a minus is a plus. Now, not this minus. Minus 2 cubed is minus 8, but you have a minus there, so that's a plus 8/3. And then the last one would be a negative what? 2. Yeah. Because then you have a minus from here, and this will be a negative 2 squared is positive 4, so that would be minus 4 over 2, which is minus 2. Now, I really don't care too much what order you do those, but I'm like Bill, I would have gone on and incorporated the outside minus as we went. But that was just too many minuses, at least the first time we do this, to do it, so I wanted to keep them separate. So 2 minus a minus 4, that would be plus 4, so that would be 6, plus another 2 there, that would be 8, okay? And you got a minus 1/3, and here we have a minus 8/3, so that would be a minus 9/3, which is minus 3, and then you have a minus 1/2, okay? Now you can do this as many steps as you need to. I have a weird way of thinking, so don't fret it if you don't think the same way I do. Count yourself lucky. Okay, so this will be 5 minus 1/2, which would be 4.5. Which I bet you the book writes as 9/2. I don't know that for a K. Oh, but they do. Yeah. Yeah.
At the beginning, could you take out a negative sign and some
Okay. You mean when you say the beginning right of
yeah, put the negative.
Yeah, put the negative out here. Yeah, you can do that. It's perfectly legal in most settings. Yeah. And then you'd have x squared plus x minus 2. And that's perfectly fine too. Then you have the minus out there, and don't forget about it. Okay. Yeah. Now, as long as you know you've got the larger function on top, subtracting from that the lower function, you better come up with a positive answer. So if you come up with a negative answer, go back and see, did you forget that minus in front? Did you do something wrong? Because you better have a positive. Now, if by chance you happen to put the G minus F, you better get a negative one because it's always loaded on that. So that's the other thing to check. Did you get the right one on top first? Okay. Several things to check there. Let's see how they did it. I'm going to erase what I did. And let's see what they did. They drew the picture. And they have 2 points of intersection. We noticed that too. You can do it graphically, but I prefer algebraically because my graphs are not precise. Usually algebra is a bit more precise. Okay? To find the x-coordinates of those points, set those equal. That's exactly what they're doing, setting them equal to each other. And they took it the way, I can't remember your name now, but you're suggesting taking. Perfectly all right. Then they pulled the minus sign out in front. Okay, you got to do it somehow. And that gives you x equal minus 2 or x equal positive 1. Okay. So those are your points of intersection, or those are your x values of the intersection. So a is equal to negative 2, b is equal to positive 1. So that determines the limits of your integration. And you saw also from your graph that b is always less than, or g is always less than or equal to f. So you put that as the one subtracted from the other. So your delta A increment of area is your alpha of x minus g of x. Delta x, and that would be your 2 minus x squared minus x delta x. Express that as an integral rather than a sum, that they didn't do the sum. A is equal to the integral from negative 2 to 1 of negative 2 minus x squared minus x dx, which integrates to be that. Those parentheses inside are really not necessary, nor are the brackets outside, but they're fine to have. And then to plug it in. Don't you love how the part that takes the most mental energy is plugging in all those numbers, getting the signs right? They just, oh, it's equal to 9/2. Okay? Without showing you the pitfalls of where the sign errors could be and things like this. Oh, there's this. As the some books used to say, this is intuitively obvious how you get here, which is usually not intuitive nor obvious. Okay, but yeah, that's the answer. Okay, if I'm not mistaken, they're skipping examples 3, 4, and 5. So let's go back to a good clean piece of, we'll go here and do example 3. How are we doing on time? 5 minutes? Okay, what does your watch say?
Don't get out at 2:25.
Yeah, okay. I want to make sure you weren't thinking 2:30. My watch is a little fast, so that's why I was asking that. Okay. So let's see if we can get example 3 done in 5 minutes. Region lying between two intersecting graphs, the sine and cosine curves intersect infinitely many times. Bounding regions of equal areas as shown in the figure. Oh man, they want me to draw this. Okay. Okay, someone tell me, I'm going to put down the x values of interest. Does anyone remember what they are? Sine x and cosine x. What would be your points of interest here? Say again? Okay. Okay, yeah, okay. Let's go 0 to 2 pi. Here is 0, and let's just make this 2 pi. What's the value in between that? Pi, and in between that, pi halves and 3 pi halves. 3 halves pi, however you want to say that. Now those aren't evenly, but yeah, close enough. Where does the sine function start? It starts at 0, 0 and goes up to 1 at pi halves. How about 0 at pi, negative 1 at 3 halves pi, and back to 0. That's one cycle. Let's do the cosine function. You want to do that in a different color? Pick a color. Second?
Purple.
Purple. All right. Okay, regal color. Where does that begin? Cosine begins at, okay, let me go back. I'll just do cosine x, okay? When x equals 0, what's cosine? 1 at pi halves, 0 at pi, negative 1 at 3 halves pi, 0, and at 2 pi, 1. Okay. Now, this is not going to necessarily be a pretty picture, but let's try it. Since I'm purple already, let's just do my cosine here, something like that. And we'll do my sine back in black, back in black, back in black. There we go. Okay. It's something like this. Now, obviously, okay. Now, what we see here, they don't always intersect, but if you kept going in both directions, they're just repeating themselves. Like if you went one more half pi here, you would be down here, and this would, let me get back to black here, would be up to there. So you see this area and that area are supposed to be exactly the same. So you don't have to do it, and then the one out here will look just like this one, the one over here will look just like this one. They just keep repeating, but the areas are the same. So let's pick any one area, like that one, but we first have to know the points of intersection. Anyone know those? It's where sine x equal cosine x. Pi force will certainly be 1. That's this one. Pi force. And what? 3 pi over 4 I think would be right about there, wouldn't it? Don't think they're the same. Does it look like maybe pi force more than pi? Yeah, that looks like it. So that would be, how many force pi's is pi? 4 force, right? And one more would be 5 pi over 4. 5 force pi, okay? Now, if you think about it this way, sine and cosine are the same in the first quadrant, okay? Same sign in the first quadrant, not in the second, but in the third quadrant they're the same sign, and that's where they intersect. Okay. At the quarter pi's, in other words, you know, those places. Okay. So our integral will then be, let me make sure I'm doing the problem right. Yep. Okay. So our integral will be the integral from, let's just take this one, pi force to 5 pi force of, who's on top here? Yeah, that'll be sine minus cosine. And then you do your dx, because, you know, you're doing your little increments. If that helps you, you know, draw in your little rectangle. Your increment is dx, and you're going from pi force to 5 pi force. If you had done this one over here, then you put cosine minus sine, but then you're going from pi force to 9 pi force. Okay, so if you pick another one, be sure you flip the order. Okay, can we do that integration? It's antiderivative of sine x. Okay. It's cosine, I heard. Now, that's the antiderivative. If that was the case, that would mean the derivative of cosine had better be sine, is it? No, it's minus sine. So this has to be minus cosine, right? Antiderivative of a cosine. Sine. But there's a minus sign in front, so it's minus sine. This is not looking promising, is it? And you're going from pi force to 5 pi force. Okay? So where do we begin? You plug in 5 pi force for the x, right? So that'd be minus the cosine of 5 pi fourths minus the sine of pi fourths minus the cosine of 5 pi 4. Oh, no. Minus the sine of pi fourths. I got carried away with my things.
You plug in first the 5 pi fourths in both of those, and then minus pi fourths.
Okay. Now, I said I usually don't like drawing graphs. I'm really glad I drew the graph of this one,
Because I can look at this and see what is, at least get the idea, what is the cosine, that's the purple curve, of minus pi fourths. With something down here, anyone remember the value of your quarter pi, your sine or cosine?
5.707 or something.
Okay, in a decimal form, but in radical form, it's root 2 over 2. And that's a negative.
So we have a negative of a negative, which is root 2 over 2 minus, and guess what the sign of that is? Negative root 2 over 2, so that makes it plus root 2 over 2, if I could write, okay? And then here we have minus, now what is the cosine of pi fourths? Root 2 over 2, so that's a minus root 2 over 2, and that would be another minus root 2 over 2. But you see, these are both inside here, so this change sign of everything, so you got how many? Four root 2's over 2, which would be 2 root 2. Now I did my math strangely.
You see here, root 2 over 2 plus root 2 over 2 plus root 2 over 2 plus root 2. There's 4 of them, but then that cancels out, so it gives you 2 root 2.
And let's see what the book got. Oh my goodness, look at that. They got it right. 2 root 2. How are we doing, Jake? But time-wise?
2:30.
Huh?
It's 2:30.
It's 2:30. Oh, okay. I went over 5 minutes, but I feel magnanimous today, so there's no extra charge. Okay? You won't be charged any more for my going over. All right. So you can feel good about that. We'll pick up next time with example 4. Now, if your book isn't following this, that's fine, but just make sure you got the material down. But let me also give you some homework exercises if you are in this book. Do any of the odds 5 through 9. All 3 of those are at calcchat.com, 7's at calcview. Okay? And that means even if you don't have this, y'all can look at that on the website and see how they work the problem. It's not as good as working yourself. Do either 11 or 13. They're both at calcchat. 11's at calcview. Do any... Okay. Yeah. I'd say do any of the odds 15 through 21. They're all at CalcChat, 17's at CalcView. Stop there. We'll pick up the rest of those next time. Okay? Good deal. All righty. Any questions? I always like to have questions. Yes?
Where do we go to rent the book? Is that online?
The bookstore.
Bookstore?
Yeah, I think so. If not, they'll tell you. You just want to rent without doing the other Cengage Unlimited, right?
I could,
Yeah, okay, yeah. Now, if you rent the book, yeah.
CHD.com. I rented mine. I could go last year from there. $12.
Yeah. If you went through Cengage Unlimited, that hard copy rented for less than it will going online. But you won't be able to have access to WebAssign, but I don't make any assignments on that. So if you want the WebAssign, you have to go the other way, right? But just renting the book, yeah, that'll do it. All right, glad to.
So we can use a calculator, right?
No, you have to do it all in your head. No, of course you use calculator. You could even use graphing calculators
They
if you
didn't let
choose.
us use calculators in the other schools.
What's that?
They don't let you use calculators in the other
They didn't let me
colleges.
use one at Auburn. When I took Calvin,
Okay, where did you say?
Auburn University, they didn't let me use a calculator.
I can't.
In his university, they didn't let him use a calculator.
Wow. In calculus class.
Yeah,
They
Auburn.
expect you to do it by hand.
Uh-huh. Okay. Well, most of these you can. I'm not using a calculator.
Like,
So.
I had to drop Cal 2 at my college
Right.
last semester because I couldn't get it.
Right.
Not without a calculator.
Do you know where Mr. Bryan's office is?
He's usually right back there. He was there earlier.
Right.
Did you see him when I was talking with him? But he has
I
a,
was back and saw him, but I was looking for him because I'm registered in physics too, but the times kind of overlap.
right.
And when I spoke with him, he said we could work something out.
Yeah.
Did you ever have a brother who came to Georgia Tech and taught?
What's that?
Did you ever have a brother
Yeah.
who taught in the Downey University system?
Tall. No.
He was an engineer.
Yeah.
Looks like he was.
Poor guy. Okay.
But he'll be back. Oh, he disappeared.
Sure.
Yeah, he'll be back for his later class.
Okay, I'll probably wait till I talk to him.
Okay.